Alright. We are back. We are back with the thing, whatever it is, the what have you. The Langjam Gamejam. Actually, let's bring up all my stuff that I need. First of all, this is our cool Langjam Gamejam. Build a programming language and a game in 1 week. This is the second to last day available because it ends on Saturday and today is Friday. But also, this is the last day I'll be streaming my work because I'm going to out of town to see friends on Saturday. So what I need to do is get this in a place where players or people won't feel like they're missing out when I do the rest of the work off stream. And we're dangerously close. Also, I'm going to see if last time I was getting driven insane because Firefox had a bug where my canvas was black because the whole thing is in the browser. Post 8080. And so let's test. So basically yesterday I developed a test system. So test analysis. And so this is what the program will actually look like in this is a working program's output in handwritten bytecode stuff. So let's get that in here instead of the actual analysis from the compiler so that we can make sure it does not work. But I went through all the trouble of updating my graphics drivers. It's gotta be... I feel like the only thing that it could be is someone suggested I ask ChatGPT and it said it was a tainted canvas. But I couldn't find any answers to that because it works in Edge, but just not Firefox. And I don't know if it's I think it must be something to do with my if we do a private browser. Oh. Wait, hang on. Oh, it just didn't work. Okay. So yeah, it's something to do with my browser settings, I guess. Which makes sense, I guess. Yeah, so basically I'm in a hell of my own design. I'm a fool and a bastard. So what else do I have here that would be causing issues? Because yeah, I mean, these three seem like the obvious things that would be causing issues. Maybe, yeah, who cares? Okay, it works on a private browser, and I prefer using Firefox for this just because it's the browser I use, and also the editor looks better in Firefox because I also made the editor on the first day, or basically repurposed an editor that I'd already made in that works best in Firefox. The text gets a little misaligned. But yeah, so there's fun things like the fact that it has the syntax highlighting for oh, well, the syntax highlighting mostly works. Oh, every time we load the image, it adds a new one here. That's funny. So what I could do is I could also just have image. Hang on, when we load an image... Oh wait, load sprites. Yeah. Let's just have the sprites here. And basically it's going to be... Let's do if path... Actually, I know what to do. If path in duet.platform.file.sprites return duet platform file sprites. And then what we're going to do is result equals let duet platform file sprites this equal results And also what we'll do here... Oh, wait, no. Path. Basically, if we have a promise already, we'll do that, and then we'll return result. And then what I'll do is, when we actually load the image, we will set this to here. Otherwise, we will... Actually, let's put this up here. Because this will actually be img. And then what I can do is, if there's an error, we will delete our currently existing path here. We will not have a promise, and we'll be allowed to try again. So this should mean that we don't have, like, duplicates of the file, but that's not the actual thing that we need to do. My main priority now is our analysis almost works. We need both phases. So let's see where the analysis left off last time. So that would be, let's go to the debugger. But okay, I'm glad that it's some sort of bizarre hell of my own design. But okay, what we need to figure out is what all of my code actually looks like. Because basically, we do our first phase of analysis where we actually get all of the variables, and that gives us each of these. So like my player is an entity of type player, and it has all of this stuff. So I think... How do I figure out what the values are? Because, for example, this player is already correctly loaded. Also, I'm going to make this a little smaller so that way we can see the whole screen here and get a reasonably large platform here. Hopefully this doesn't, like, get copyright claimed. That tends to be what happens with indie, like Japanese indie rock. But okay. So this is set up correctly. Let's also get dependencies. Printable or readable var. Because we actually need our dependencies here. Basically for debugging purposes, to figure out what on earth anything is. So we need to resolve dependencies. Hang on. What are the main things we need to do? We need to resolve undefined types by going through the list of dependencies for each variable. Get the update and storage types. So resolve undefined types storage. Or storage and updates. Because basically every single variable has a few things. It has a data type, it has an update type, and a storage type. Storage type is effectively like static versus instance variables. Update is whether the variable needs to be checked every frame, or if it's like only once, or if it's something else. And basically, if it's once, it's probably guaranteed to also be like this. Well, I'll still need to decide how I want to do that, actually. Because it is possible to have things like, if I want each variable to have a different, like each object to have a different speed, for example, I would need to have the update be once and the storage be anytime. I guess I could just have it be like a message, like a, you know, custom thing. Yeah, I'll figure that bridge out when I get there. For now, let's just keep the code working as it is, because all I want is the player to be able to move with the arrow keys from code to screen. Basically, recreating the thing that I have, my test analysis that already exists. So yeah, basically, if val.dependencies, or let's do let node equal, no, var node equal variables val. And this is actually going to be var name. So yeah, var name equals a printable var node. And then if var name dot type, or I guess if type in var name and var name dot dependency dot length. So basically this means that if we have the type and we have the length, I'm almost certain that means that we don't need anything fancy here. Why is this undefined? Update once storage undefined. Oh, because it's literally, I just literally said that. The type is undefined because we don't know what it is. Okay. So we're going to also have like a let processed type. Actually, wait. We don't need that. Or var name.dependencies length. To do, figure this out. Basically, what I'm going to do instead is if we have this stuff, we'll do that. And then let's do if Actually, what I'm going to do for now is just continue. To do var name. And you know what? Let's actually just have... I don't care. So we'd have to do our actual, like, going through the dependencies to figure out the type and do that stuff. But otherwise, for things that are already working, what we can do is if var node update equals update.once. If integrate. Actually, we don't need that. Actually, we do need that. I know what I need. Storage equals storage.global. I'm going to try to figure out what the test analysis would mean. Let's get a copy of this in another file so that I can just look at it at the same time as this. Okay. So we have all of our things here. Type entity player, count. So we have all this stuff. So compute allocation. So anything that is a global and that we update once, we would have an allocation here. And then in creation, okay, I see what it is. All global variables will only have an allocation. So basically what that means is compute, or let's call this var node. Oh wait, no. Compute dot allocation dot append or push var name and this would be var node code flatten. How do we get infinity in JavaScript? Oh, that seems easy. And this isn't my first rodeo. We need to flatten this bytecode that we have from a list of lists down into just a massive, like a collection of things. And so that means that for each of these, it should be able to do that. So yeah, that seems good. And then else if integrates in var node, what we would do is actually that means what I should do is, hang on, I have an idea here. Let r equal that. r.code equals oh wait, no. This is our readable thing. What I need to do is integrate. We need to have this instead. So an initialization and an integration. Okay, I guess I'm fine with this working the way it does. Basically, what this means is we have entity.compute.frame push var name. I mean, I guess we'll just get this code here as like I don't care that much. I could turn that into a tiny function. Oh wait, no, and this needs to be actually .integrate now. And then we'll push our other code, which will be in the creation. Oh wait, this doesn't need to be a listed list. It needs to be this. Yeah, it's not a list containing a list. It's just one list. Like this, basically. And I think That should be reasonable. So what we would do here is we would walk the dependencies and called functions to determine types and overloads. And that could be quite difficult, because basically what I need to do is go through every variable and all their dependencies and resolve the types of them from, like, the bottom of the tree to the root of the tree, or, like, the leaves to the root. But okay, otherwise we just have... So if we have an instance variable and it does not have this integrate, that means that it's just a thing that updates every frame, which would be entity compute frame push there. Actually, we do have global variables that are updated every frame. Movement is one of them. So let's do, like, if... Let's see, this is too harsh for me. I need something that's milder for my little brain. Yeah, punk alt rock is not for me in coding time. Okay, so basically I know the difference. So if var node.update equals update.frame. Actually, let's first do once. You know what? We have like 17 quadrillion functions here that are all doing the same thing. So what I'm going to do is just like let code of node or function. Basically, we will return node code flatten infinity. So now what I'm going to do is just going to get all of these. Oh, wait. Not going to quite work. Okay, code of var node. Okay. So yeah, because we have a lot of similar conditions here. So if this variable only updates once, it either updates at the time of the initialization of the entire class, if it's a global variable, or it initializes at the creation of the variable. Otherwise, var node update equals update dot frame. If there's an integrate in var node, we do that. Otherwise, we do compute frame push. And I think here we actually want to, we would need to disambiguate the VM code. Anytime we have vm.call, we actually need to determine the correct variable here. This is basically determining like a... Like, SS means a scalar and a scalar. Because this is a global variable, so we only need to subtract, like, one number. Okay, so I'm going to have to figure out if that's actually put in here properly. I think it's not. Because, yeah, if we go to movement, for example, it should know its type. Oh, wait, hang on. Dependencies is dependencies. Dependencies val.dependencies. So when do we not set this? I know what to do. I'm just gonna set here or var name dot dependencies and val name dependencies length. In operator for type my player. Oh, wait, okay. Cannot use in operator to search for type in my player. So that's 218. Oh, that's because this seems to be our node. Can access property length, var.dependencies. Okay, so we got a little closer. So, for example, it knows that the player is still here. But, yeah, as I said, this call... Well, I guess this call is known. Okay, that makes sense. And then we'd have these... What if I just make it lowercase? Var name now capitalized. Oh, right. Uncaught error node.code.flatten is not a function. Flatten. This is why we compile often. So what is our node.code? So code is this. I swear there was a function called flatten, wasn't there? Hang on. JS array flatten. Oh, flat. Of course, silly me. We're not flattening it, we're just flatting it. I suppose what it is you're getting an array that is flat, so it's like more like a property of it. So can't access property length, types values, val name is null. Oh, I see what we need to do. What we need to set this as is if it's an instance variable. No, storage instance. So basically, if array is array val type, no, what am I doing? For each variable name here, we need to actually have if var node dot storage equals storage dot instance entity values var name equals an empty array, because this means that we now have 0 entities allocated of this type, which means that that variable is empty. Almost. In promise, type error, can't access property length, type values val name. I guess what I'm going to do now is let's just print... So once we printed this, let's just print our console log. There should be an entity type, or type name, I think, somewhere up here. I guess I'm just going to do file name, entity. Actually, type 1. Because we get the type name there. Okay. Now what we do is we know what the game is. So, for example, it has one object created at allocation. That is a player. It has all of its functions. It's beautifully described, exactly as it should be. The player probably has... It's surprising that it has as many things as it does. But okay, that's fair. One issue is that this isn't the correct thing. This array here is not actually the instructions that it needs. Yeah, there's several issues with this, but that's okay. Alright, let's do actually a varnode.type. I think I should probably do an equals here, strictly equal. Okay, now it tells me a little bit better which of these is not properly set up. Okay. And then we go to the player. And now it doesn't have anything in it because there's no variables that it's being set properly. Wait, why is that? Oh, wait. How does it know all of these? I didn't actually resolve these, I don't think. Like, it shouldn't know the type here is an array of 2 real values. I think what I'll have to do is I'll have to figure out the dependencies, basically. That's the issue here. But okay. In promise type error can't access property length of type values val name is null, and that's because values var name type.values val name is null. Let val of type.compute.creation. Okay, so our issue here is that the sprite should not be created at creation, it should be created at allocation. So why is that happening? Because, yeah, we should have if a value is being updated once and it's global. Okay. We need to redo this. Okay, so for each of our named variables, this we should know is, its update is 0, storage is 0. That means that it's a global constant. And so we should see that in here, storage global update once. And that means we got this, so yeah. Value store name, or storage global, etc. Okay. That should be good. Then we got a sprite. So the sprite should be... Oh, it doesn't have an update there, because we haven't actually resolved it yet. So what we should do is, if value storage equals storage.global, or it equals undefined, I know what to do. We should just swap this to be instance, else that. So basically, we should check if it's equal to the instance storage and set it here. Otherwise, we set it to default to an allocation variable. Okay, so that was part of the battle. Okay, good. So now it actually is setting these here. So it should have done, for example, if we run that. It was getting closer. But okay, now we can see a few other things. It expected, for example, a function to execute. And that means that here, anytime we are getting a function, it should go through all of the instructions. Let's call this, I know what to do. Yeah, we're going to need to determine the value here. Basically, this function, we need to get this .s here. We need to verify that we are using a scalar. And that should be known right when we compute this, or right when we do, yeah, when it's storage global. Here we would do that as like global, or like scalar. Or let's say vector. Okay. Oh wait, I forgot. We need one more thing here. So we can guarantee, for example, that if there's an integrate in here, if not... Oh, actually, we can't guarantee that here. Let's let vector equal, or is vector equal, var node dot, storage equal storage instance. So it's possible we could have a variable that does have this initial value, and then it integrates and it's a global value. At least that's supported by this analyzer. And so yeah, there's like a few different types of nodes that we can have that update every frame. One has an initial value that's created at creation, and it has a frame value, which is this integration. Otherwise, it just has a value that's updated every frame, and not a value that's initialized when we create the variable. Okay. So yeah, I think now what I need to figure out is, a lot of variables that are called with more than one instruction, we actually don't know what arguments it takes. Because we actually need to know, for example, here, that both of these are global variables. And then we can disambiguate with this.ss. Ooh. So I could actually figure that out with, I have a good idea. We need to slightly change the, like, intermediate format, so this code of will actually have a more important role than what it is right now. So yeah, our code will not just push these. Well, actually, it will push these. Yeah, that should be fine, actually. Because basically we get the last instruction. So the first op of the last instruction tells us whether it's, you know, what type it is, like a call and stuff like that. And we can do that in here with code of before we actually do the things here. So we'd like resolve variables. Okay. But before I get too lost in that, I actually want to first get all the dependencies of a variable. So let's do analyze expression. So resolve accessor. Okay, and anytime we do this, that's the only time right now where we actually know that we're getting some sort of accessor. Or some sort of dependency. So what I should do now is, when we do, for example, a function call, let deps equal an empty list. And then if arg code.dependencies and arg code dependencies length deps equal basically we will add all of our dependencies here. And I think that's the only time. No, actually we do need that in one more place, which is values list here. Actually, there we go. Let's put that in the same place. We actually need it in several places. Okay, let's try this now. So it should now detect properly that, like, a lot of these code... Oh. Pause that. Yeah, now it's actually getting into the VM. It just doesn't know what is what. What I could do that could be kind of cute is resolve it just at runtime at the first invocation. So, because we can just tell, like, that actually might be the easiest place to tell. Basically, here, we know that we're calling this function with one argument. And if that argument is an array, we can just call .v, otherwise we call .s, and we can actually just set the instruction in the buffer. I might do that, actually. But okay, another issue that I'm having is... it's still somehow, like, getting all of these, even though it was supposed to be doing a to-do. So yeah, if var node type is equal to undefined, is this always false or something? You know what, let's just set the type to null. So, like, let's do default code. Actually, type equals. Let's just do, like, an unknown here. So yeah, our type is going to equal type unknown. So yeah, like... so I will explicitly set that there, which makes this a lot better. Active file that. Okay, so now... because yeah, I think undefined is causing messy things there, but pause that. Okay, so now it has that. Where are my dependencies not coming in? Dependencies. Is there any place where we aren't setting these now? So our code dependencies and dependencies length. Because yeah, expressions, value lists, and function calls should all have those. If we go to, for example, the position, oh yeah, okay. Wait, no. It doesn't have the thing. How is movement known? Oh, because it's an array of unknown. That's not right. Hang on. Like, that should know that. So yeah, if ac.local default code, if not type in there, otherwise code equals ac.ref.type. Oh. This should actually be... oh, wait, no, that's fine. Hang on. Let's get this a bit more over here, perhaps. That doesn't matter. So if name.type is not equal to blah, blah, blah. Wait, no, we don't need that. We need accessor code. Basically, my function should know what type it is. So for example, our accessor node here. Oh, wait. Okay. So yeah, player.create. It knows that stuff. And then we should have input right. Okay. So this should know, for example, that it's not a local. And the AC reference, it has a type. Good. And so we let our code equal this, which has no storage, no update. Actually, wait, do we not set the storage and update here? Oh, we know. Okay, we do. So otherwise value in ac.ref. We just do that. Okay. Basically, this tells me things that are correct. So, like, we know the type of our value. So, does that mean that whenever I do vm.array, am I not doing the code properly? So, element type should be equal to, let's do, like, type.unknown. And let's do, like, let, or function rectify type. If element type, or let's do like node type. So if element type is not equal to, or let's say equal to type.unknown. I have a better idea here. Else if is not equal to type, return false, true. Okay. Now what we do is if not rectify a type. And then actually we should have this rectify up all the way here. Oh wait, but that's going to be kind of a trick to deal with. So yeah, now what we need is actually type A, type B. Let's call it type 1, type 2. So this would be if type 1 is equal to type.unknown, return true. I know what to do. If type 1 is not equal to type 2 and type 1 and actually let's say match, or like okay, so basically this means if we can unify type 1 and type 2, we just assign type 2 as a result. So let's go back to lm type. So basically every time we do this, unify. So if unify lm type a dot type, we'll just do lm type equals a dot type. Else this is now what we do. Wait, hang on. Well, that explains... Well, no, that doesn't explain anything. Wait, what the heck is arg code.type? Okay, okay. I see my failing now. Yeah, so we don't need that. We'll just do unify here. And so that means every time we do this... So if arg code type and xp this... Okay, if we don't unify this... And actually, here what we can kind of do... I'll ignore that for now. Okay, so we're going to do type 1 as that, or type 2 equals type.unknown, or type 1 is equal to type 2. And for property, or for expressions, we don't do anything with unifying the types right now. Okay, let's see if that works. Because it seems like part of the bug was the fact that, I was not actually getting the type of the value here. Oh, wait, hang on. So basically, vm.array should know the type of its result. And also, that means the type of this should actually be elemtype. And then this here is actually exp node.children length. So an array, we actually know that this is a fixed size array, and so we know the type of it here. And then I'm going to pause because we're still not getting everything here. Yeah, you know what? I'm just gonna fucking let this overload. So what I'm gonna do is let's go to overload. Overload function ref. And then we'll have like an offset here. So like if type of function ref equals function, return function ref. This is so silly. Resolving function overloads, and then we're going to reinsert this pointer here, else we're going to get the argument length, so like match, or like let length equal function ref dot args dot length. Let code, or let exp equal nothing. Or let I equal 0, I less than length, I plus plus, we're going to actually peek into the stack. So like let s equal, so yeah, literally overload the function based, so overload the function and insert the correct call based on the arguments on the stack. And actually, let's do else if type of function ref equals string sol.error should have been overloaded. And this would be function ref return null. Actually, let's just do else if type of ref equals object and args in function ref. Actually, let's do this a little bit better. Function ref dot type equals type dot function. At first invocation, and insert the correct call. Wait, actually, we need to get the overload after the arguments. So each time we do this here, we actually should do args length equals args2 blah. And then we do this here, where we put the arguments here. And that would actually be args. Let's do that. And actually, that means that we don't even need this here. We can just do overload 1 args. In fact, we don't even need that. We can just do overload args. Because we always know that let function ref equal arg1. And so this is actually going to be args now. And so we can just do args.length. And then if... Actually, we don't even need this then. So if array dot is array oh, wait, this isn't going to work because sometimes we do scalar operations on arrays. Basically, like, okay, so none of this will work. We just need to resolve it better at an earlier point. And that was a funny idea. But yeah, we basically can't resolve whether or not it's an array because it's an actual, like, array type, or if it's an array because it's multiple values being computed at the same time. At this phase, it'd be way too late to figure that out. So yeah, let's make sure that I properly undo everything that I did here. Okay. Because we should at least figure out a few of the things that we have here. So, for example, this movement should not be that. Oh, it should be that because our expressions don't know their values yet. Yeah, so we need to figure out, for example, the types of things here. So, like, type should probably be... This should be unify. Right, let's say if unify type this. Type equals arg node type. That should help a little bit. We're basically assuming... Oh, arg code. So many things are called node. But okay. What we actually need now is we need to figure out... movement. Is movement getting its position? Okay, now it knows what it is. It is an integer of 2. And I'm actually going to change that from a type.integer. I'm going to change basically every... Well, no, those are fine. No, you know what? We're going to change these to real. And these as well. Basically, I'm going to avoid having things that are of an integer type because I can't be bothered to overload math types even further. Okay. We're getting a lot of things that are now... that believe themselves to be valid. However, there are some issues, like this dependency, this position should know... Oh, it's because the integration has the dependencies. Okay. And they're also undefined for some reason. Oh, and also... if AC length 0 in duet.overloads... Wait, hang on. This should be text. Wait, hang on. Actually, that shouldn't be text. This should be... What the heck am I looking at here? Okay, this is an array of strings. That explains that. Okay. That's supposed to be there. And then what we do is when we integrate... So, variables name dot dependencies equals... You know what? Let v equal variables name. Because we need a lot of v here. Because v.dependencies equals v.dependencies dot concat v.integrate dependencies. And we actually need to do some unification here of like to do unify things here. So basically like if a variable depends on itself, it always updates each frame. And so we can actually do that here, basically. If name in v.dependencies dependencies b.update equals update frame. So let's see what the dependencies look like now. Okay, so now we can see it is not updating properly. If node.children.length equals this. Let's go through dependencies. So if, let's say if var name in var node dependencies, var node update is always equal to update frame. And that should mean that now, still not updating properly, even though I explicitly did that, where its var name type is equal to that, or it has dependencies and it has a dependency length. If itself is in dependencies... Wait, hang on. Oh, it's because this isn't the same thing. We need to do index of var name is greater than or equal to 0. Then we add the dependency. Okay. So now we can get things, for example, the player should know that it computes itself every frame. Oh wait, let's do that here. Yeah, so we have that. Updates every frame. So yeah, movement updates every frame. Speed updates once. It is a global. Sprite updates once. It should be not undefined. It should be storage. Where is that being done? That should be fun call. Where would that be? So if the type is a function name and it's a type overload, local functions not implemented, expected a list of arguments for the function. If arguments children length is, so if we're calling it with a different number of arguments, where do we get our code type? So we should have storage here as storage.global. So yeah, we get the max of our update. Max of our storage should be, So that means that probably this arg code for the individual variables isn't defined. Oh, because we don't have a storage here. Okay. Yeah, so we never set... So yeah, a function call does not know its storage. Or if it's a... Let's see, I know what to do. Arg code.storage and math. And we'd actually do the same thing here. Because it basically seems like we're doing something funky with math.max and undefined. But okay, so now if we go to movement, okay, so yeah, it's a global variable, it updates every frame, it's two real values. It is basically, we're reading two variables, we're subtracting them, reading two more variables, subtracting those, putting them in a list together. Hmm. Is there anything that we don't have that we would need to figure out? I think what I'd have is a type check function inside of the variables somewhere here. It's like after we do all of our analysis. I think this is fine here. Oh, and actually we need, okay, yeah. We don't need to do anything fancy there. Hmm. So what I'm actually going to do is if varnode.dependencies index of varname that, and, or I guess, yeah, we should have a dependencies list for all of these. So yeah, any variable that depends on itself. Every frame. We should also have the declaration for each of these. So like, when we create the variable, yeah, we should have this node here. So like value 1 like dot node, like our parse node equals node dot children 0, probably like that. And so that way, or we can get like a, yeah, that's fine. Because basically now what I can do is I can print an error when we have issues with it. Like, for example, if it depends on itself. Let's see, let's do that in index of here, if not var node dot integrate, or if not integrate in var node. Basically what I'm saying here is we can't have something like movement equals movement plus 1. This is not correct because we need an initial value. So we would just do an error here. Variables that depend on themselves must have an initial value in the format varname equals initial value semicolon integration. And basically, swap this for that. There we go. So yeah, variables that depend on themselves must have an initial value in the format varname equals initial value integration. And that would be the var node dot parse node. Okay. So what I could do is just have like speed equals speed plus 10. And that tells me that this is invalid. Because variables that depend on themselves must have an initial value. And so we could have, for example, 0 and speed plus 10. And now it works. Beautiful. And what would be really nice is to be able to highlight the text that has the error and it tells you what the error is, but I'm not smart enough to figure that out yet. Interesting that my code... Hang on. Spooky orchestral music. Maybe this will be what my brain needs. Let's have this be like this. Initial value integration. Hmm. Hmm. What I'm going to do here is equals null. So whenever I do this... So yeah, we don't need that there anymore. Okay. Hmm. I'm getting kinda lost in this. So I think what I need to do is I need to type check right here. Var node. Or, yeah, I think here's where we need to actually have a type checking system. And that would be right, we can just type check. Well, let's say var name, var node. And that's fine. And this is where we actually are initializing values. So yeah, we're creating our computation code and stuff like that here, rather than doing anything crazy with the stuff. And then console log entity type 1 entity. I don't need that right now. Because yeah, we'll get our entity, we'll get our errors. Let's do like type check code equals node vector. And then what we'll do is like, let's code equal type check code. So I think this would be like type and code. So basically we're getting the type of this value, we're getting the thing here, and I think this would actually, let's tell it info equals type check code. Well, info equals that. And then what we do is var node dot, we basically need to kind of re-resolve a lot of stuff here. So our var node like dot info. And I need to double check what we'd have. We'd have like update equal info update var node dot storage equals info storage var node dot type equals info dot type and var node dot code equals code dot flatten info code flat. Well, actually, yeah, we don't need that. We'll flatten the code as we go. Because yeah, I think what I need now is when we actually have a printable var here, this needs to do something a little bit better. Okay, I think I understand what I want here. When we analyze an expression, we don't just merge the code into things. Okay. I see. I see. So yeah, type of expression node that. So we actually don't do any of our unifying things until we have, like, a list of arguments. Basically what I'm saying is, name equals resolve and accessor. We don't actually have anything... Well, actually we do this. We don't have our updates, we don't have our dependencies until we're at the end here. Let's let code equal default code. And what we're going to do is we're actually going to have children of the code, I think. I know what to do. I don't think we bother with any sort of unification here. Instead, what we're going to do is we're going to do code push arg code. And we don't do any of our dependency resolution here. We're just going to add that. And then we're going to add the final code, which is an actual array of things. So that's code.code here. And then actually here we'd have ref.return. This feels fair. And actually here we can still have this as an empty list. Okay. I'm doing some weird transformations. Basically, the main thing is, we're actually going to have our, these nodes are going to keep the type information of all of their sub-expressions. And so I think what I might want to have is actually like a child node. So for these analyze expressions here, let's see, analyze expression would have, let's say, so a dictionary, very daring. Basically, it's going to have our type, updates, set type, update, storage. We don't need dependencies because we'll resolve that later. So yeah, type, update, storage, children, code. Children is a dictionary, no, array of sub-expressions, code, unique code appended at the end of all sub-expression code. Okay. That's how we do that now. And so our default code will actually be say this. Do I even need default code? Well, I think it's fine. Yeah, so we can resolve accessors fine. So now the big thing is, oh wait, no, we still need dependencies. Well, I think children will be fine. Because yeah, now what we do is we have like VM local this, AC text this. So yeah, for each variable, we would have to like resolve these dependencies first. Okay, that's fair. Function name. Okay. That's the same there. We'd have no children. Here, this is also correct. We just have the code there. When we analyze the expression, there's only a few changes that we have throughout this. One is that now we don't have the dependencies as a... so we don't do this... This is going to be now children. Or let's call it args. No, we need arg nodes. Arg nodes push that. Actually, that means that arg nodes should just equal args.children.map analyze expression. And then our code would equal something else. So yeah, let result equal this. So we can actually now, we don't even need this args node here. Yeah, let's check everything that we can check. So yeah, basically, all of our children are just this, and then we just do result.code or result.code, and we don't even push here, we just equal. Okay. And I think we don't even need to have the... Like, this will be part of the type checking instead, when we do all of that. Because we don't actually know the types of these variables yet. Well, it'd be... Well, okay, actually it's fine here. Yeah, because both of these... We don't actually check the individual types of the arguments until later. And also that means that we should have the node here as, or parse node, as probably exp node. There we go. So yeah, each result should also contain its parse node. Which actually, default code node parse node. So yeah, every single time we do that, so that way we can properly get any errors for the future. Okay. And so yeah, any time at all that we do default code, we're now putting this here. Okay. Anywhere else we use default code? It doesn't look like it. Okay. Yeah, so now what I do is I do a similar thing for example, value list. We're just going to have... We don't have any of this stuff anymore. Because what we'll do is let results equal... I guess it's just going to be type equals type.unknown. XP node.children.length. Children is exp node children map. Analyze expression. Node is expression node. Let's say update is update dot once. Storage is update dot or storage global. Is that everything we need? Oh wait, no, it's parse node. So yeah, we have a parse node type update storage. or parse node type update storage children code. Oh wait, we literally... Yeah, and we don't even need to set that now and in a particular place. So yeah, result. Parse node. Update, storage, type. I'm going to put type up here. Children, code. So, do we even need anything crazy here? We can just remove this and just return right here. And we don't even need element type. Because, yeah, we're just going to type check as a separate phase once we have all of the children of all of these analyzed nodes. But okay, a parse node expression will be slightly different because we actually need to slice one out of here. Which actually... I guess that's fair. We're going to let... Oh wait, we just return here. Parse node, exp node, also semicolon. Type is going to be type unknown. Update once. Global. Children will be exp node children slice 1 map. And actually, we still have this here, and also we can still have this here. Something scared me, but I don't know what it was. Probably nothing important. And here we're going to have code is equal to vm.call. It's going to be this exact same thing here. Okay, so now the structure here is much easier for me to understand, and it's a lot easier to, it's a lot more compact, because now we have a separate type checking phase. And yeah, we do a lot of checking here before we just return all of this stuff. And actually, I'm going to slightly make this more compact. So, ref.async else vm.call ref args children length. And we don't even need that anymore. Okay. So yeah, now what we can actually do, so for printable vars, it'll be slightly simpler. So like our code will just be equal to, let's remove this, actually. Oh wait, no, that's fine. So yeah, we don't have any dependencies anymore, because yeah, we have type is readable type. That's fine. Update is update. Storage is storage. Code is code, which is actually just going to be val code dot slice. One? No. VM names val code 0. Now we know that this is just going to be one instruction. So it should always look like that. And then for our children... Oh, wait, did I miss something here? Wait, we don't need 2 arrays here. We just have a list of one value concatenated to a thing. And then children equals val children map... How do we map a dictionary? I don't think we can. Let our children equal nothing. For let c of val.children. No, this is going to be c in. Val children are children. C equal printable... Let's call it a printable expression, actually. So printable expression. Val children C. This music's spooky. It's not bad, but yeah. Not easy listening. Oh yeah, fun thing about, again, playlists on YouTube. If you have it shuffled and looped, and then you press the next button on the last song, it ends the playlist. It does not loop the playlist, it does not shuffle the playlist, it just ends. Okay, now we're getting some relaxing steel drums. Okay, this is going to be our children. And then, yeah, if there's an integrate, we'll have that also be a printable expression. Okay, is there anywhere else where I don't have dependencies? So yeah, now when we do this thing here, we're not going to do that. Oh yeah, because we don't even need this anymore. We just analyze the expression. So this is just a child that is special, because it's not actually integrated like the rest of them. Okay. So let's see our type checker in action. Let's make sure that the code actually works. Okay, it does. Type check. So yeah, let's go to the console. So yeah, we have a variable here, code. Let's see. What is happening with our code? Our code should have not any instructions there. Is that because VM names val.code.0 concat val.code slice 1? So what would this be? What is this supposed to be? I see, I see. It's because we still have, 0... We still actually do have code that has that, hang on. Git diff. I removed too much stuff. So we need to go back to my readable code. Should be printable expression readable code. Yeah, we need this. Our code here is equal to readable code. Put this back. Okay. So we'll just have readable code of this. There we go. Okay. So if the first instruction is itself an instruction, or if the, like, instruction is actually code, not just one instruction, we'll just return that, because that's a list of instructions. Otherwise, we return that. Bring this back. Can't access property index of varnode.dependencies. That's because we no longer have varnode.dependencies. We do that somewhere else. Okay, so if we look at the console now, let's double check our code. So yeah, constant player, constant one, constant that. And so this should have, it has the type, it has the update. Is there anything here that we would need to figure out differently? I think each child node should actually have dependencies. I guess we just resolve dependent variables. And then if they're... Check code. We don't really need the variable name here for now. Well, we kind of do. Because we could have more advanced things here. But okay, let's type check this value. So what I want to do is, we know the type of this, so... That actually means we probably don't need to have any of this update storage and type here at all, because we're just going to be doing, you know, the type of the code and then the, like, children. Well, actually, we do kind of need that. What the hell am I doing now? Okay, keep that there. Let's just do if type is not equal to type.unknown. Or actually, let's do for C. Or let's let instruction equal code. Because basically, there is exactly one instance where we need a fancy function to get the last instruction, and that's right here in the in our object here. So like function last instruction code if code 0 Oh, wait, actually, otherwise we return code 0. Okay, so this is our fancy thing. They should just give us a VM instruction because we want this value call. And basically what we do then is with each value, we need to figure out match. So let's I have a better idea. If children length equals 0, we should just have all of the info that we need. Or we can do like node.code equals code flat infinity return node. And I'm gonna be updating all of these nodes in place, I think. Yeah, I'm fine with that. So yeah, we'll just like type check in place, and then we can actually, yeah, we're not even gonna have a thing here. Otherwise, we'll need to do something fancy. And so I think now we can actually figure out let's do if node code 0 node.code 0 only one type. Or let's do, I have a good idea. If storage, no, node dot type is not equal to type dot unknown. Okay. If there's no children and we know the type, then that means the code must already be validated, and then we just return. Because everything else, by default, just has a type that's unknown. Or let's say, like, if valid. Or let's say function known type. Return type is not equal to type dot unknown, and or actually let's say if type is equal to type unknown. return false. If, let's say type 0 equals type dot unknown, return false. So basically, I'm trying to figure out when we know the value of a type, or when we know the type of an expression. And there's only two conditions where we know it's unknown. If we actually just have this as unknown, or it's an array type, and the elements are unknown. And so that means, I think here, if we have no children that need to be validated, and we know the type of the node, we just flatten the code and return. And so this means that we have a constructor. So I think now, if we go to type check code, oh, got keyword return instead. Wait, what am I looking for? Expected expression got keyword return. So that's probably because I didn't do something correctly somewhere. At 1997? Oh, I see. Why is there a return there? Okay, so it's getting a little closer. And then we don't even need any of that. Because, yeah, for now, there's no, well, I guess we can keep that here. Actually, we can just have this here. So yeah, basically this will be a recursive function where we just go through each sub-expression. So for let I or like let's do node children dot map. Nah, we don't need to do that. For I equals 0, I less than node children length. Type check. Bar name, node children, I. Actually, isn't it that map is faster? So basically, we just have like map C. Oh wait, no. Yeah, I won't bother with that. But okay. Then we update all of the children, which should be pretty easy. Code of is not defined. Yeah, so now what we actually have is, we don't do any fancy resolutions here. We just do var node code. And this should be able to determine correctly our vectors and things like that. So we don't even need that. Wait, what? This should be integration. Yeah, okay. I must have forgot that. And I'm just going to compact this just a little bit. Because we don't need everything to be like 50,000 lines. Oh. Okay. So basically, apply all the computation things after resolving types and overloads. Okay. So we're getting a little closer. So yeah, we have a thing that has a unknown type. And our code should be, it's a call async, and we need to get a value from here. And so we need to know that, we need to know all of our arguments. So we have children. Okay. And we know the values of these, so we can actually do constants here. The voice is distracting me. Okay. So we're going to go through all these. So player, node, so this should be known. So yeah, we just set the code to call all of our stuff, then we return. And we can continue on. For example, the sprite. What we need to know is all of the children nodes. We need to unify all of our children. So that means... Oh wait, why am I returning there? Oh wait, okay, that is correct. Yeah, because we know that that's true. And so yeah, then we'll type check that. So yeah, now what we need to do is we need to unify for... I guess this would be just unify var node. Let's just do like let how do I do this? I guess now what it's going to be is node.update equals max. I think every time now we have this here, so I'm just going to do node. Let's let this equal this. And you know what? Actually, I'm pretty sure I can do node children for each. And type check n. And then when we are updating, we will do node.child or just n dot. So node update n dot update. I'm going to change this to C. Node dot storage equals max storage c dot storage. We need to figure out how to unify the type of this. So I'm just going to do function unify type 1, type 2, if we need to get the instruction here, actually. So let instruction equal code 0. Because we actually need to figure out this right here. Wait, actually, we need this to be code concatenated with the code. So our code will be at the very end, which actually we can just do by, well, that's fine. Basically, I'm trying to figure out all of the possibilities for our instructions. We have, I think we only have 2 possible, or 3 possible types here. Either vm.call, vm.async call, or vm.list. No, wait, no. vm.array, or vm.local. And what we can do here is we can go to, let's gather dependencies. So we should actually not have this variables here as I guess it's okay. What we'll need to do is let var, no, I'm fine with, basically anytime we set this here, so value 1 dot order equals I. So the variables will be listed in order, so that way we can figure out things like what order to resolve dependencies, like if it depends on the previous frame versus the current frame. And that'll help things like resolving the types. Function gather dependencies node. Let's say var name. Well, I'm trying to figure out a lot of stuff here. Also, when does printable expression run? Interesting. It's not run until much later. But okay, we analyze the expression. And so this is when we're doing our, like, phase 1 of analysis. And then we, like, print it out. And then what we need to do, so let's let dependencies equal gather dependencies. So basically we figure out all of the dependencies of every variable here, I think. Do I need to do that here? What exactly do I want dependencies to be? I think I want it to be a graph. And basically the way that it would work is we'd have like we'd have all of our top level nodes, and then each one of those would have dependencies. And then anything that depends on some other node, or any variable that depends on a variable, would be strictly above it. And then we would go through in depth first order and like resolve the types of each of these one at a time. And so that way then we can finally resolve the types of these once it's done. Okay. So that means that what I'd want here is, if we go back to my duet file here, we'd have like sprite. So like graph. Actually, we just have nothing here. And then like movement, no dependencies on local variables, so that's what this is all going to be about. And position depends on movement, and on speed, and on nothing else. And then we'd have frame is nothing. And basically now what we would need to do is like for let var in, we do like type check var. Or let's say this would be var name. I guess? No. These actually do need to be dictionaries. Let v equal, or like let deps equal var name. And then we'd have like checked equals like, you know, all of our, these would just be a dictionary of these here. So like let's do like for let d in deps, or let's just do of deps. No, we actually do need in, because we also have this. And like, if var name in dependencies, return checked. Oh wait. Var name. Okay, let's put all of this where I can figure it out. Well, no. What the hell did I just do? I can't expand. Oh, okay. That's what I did. Somehow. But okay, what I'm trying to figure out. First of all, we'll need to figure out how to gather these, but that's fine. Wait a second. Okay, I see. No, these are going to be flat. Because we have all the variables here, so like let's do that. So if our variable name is in checked, and also position depends on itself. And so that means that it should have an initial value that can help type inference things. But I'll ignore that for now. Okay. So if we have our variable name in checked otherwise, for dependencies in those, so let the of dependencies So for each dependency, we'll just type check I. Okay. Okay. For each var name that we're type checking, we type check its dependencies first, and then we should be able to like use that when we're doing this. So like let's do like let var node equal variables var name, and then we do like return check expression var node. Okay. And then we'd have to do the same thing that we're doing here with the var node, but now we should have all the local variables done. And also let's do like yeah. Basically if dep equals var name, continue, dep equal that. Okay. So what I'm going to do is like check var. So yeah, dependencies. So now we actually do need the dependencies again. So default code, by default, we'll have dependencies here. Because it's extremely easy to figure out the dependencies because they're only the local variables, which means that there's exactly one place where we actually need them, which is in the accessor code here. This is now, we don't have children of it, we have a dependency of it. And then what we can do is we can go through all of our dependency code and we'll basically bubble up those dependencies from the bottom to top. So yeah, let's function dep unify node, or let's say var node. Let's call it an expression node, because this is an analyzed node, and it's going to be let d equal exp node dot dependencies. Is there a reduce function in? Wait. Oh, I see. It's here. Like if I did like let a equal 1, 2, 3, let or a dot bold reduce a b a plus b. Okay. So I'm going to do then let d equal, can we actually concat with a, okay, good. We can have a starting variable. So we're going to do return dependencies, or no, exp node dot children dot reduce concats. I think I can do that. I'm gonna see if I can do that. A equals, so it'd be like 1, 2, 3, 4, 5, 6. B equals 0. And so what I'm going to do now is a dot reduce type cats b. We just do AB. Okay. Because that's a thing that I do a lot. But okay, this means that we get all of our dependencies here, and we'll just add them together. And so for v in let var name in variables var name. Can we also do like a dot unique? Because I don't really care if there's like redundant dependencies. Yeah, I don't care. I'll just not bother with making like a unique set. Oh wait, actually we need to do C, or this will be deps and node, and then we do deps concat dep unify node with dependencies here. So yeah, we basically get our dependencies, and then we will concatenate that with all of our other dependencies. And so var name, or deps var name, equals dep unify variables var name. Okay. And so what we'll do, for example, is like if var name in let's call this check var. And then here we'd actually do check exp var name c. And let's let checked okay. So if var name in checked return. Okay. Otherwise, let node equal variables var name. Oh wait, we'll just do that here. Because basically we'll just have all of this, for example, and we'll just do checked var name equals check expression var name variables var name. Because this will basically have everything that we already have here. And eventually this will all work together. But now what we do is we do the same thing that I have here, where we check the variables of all of the we check var here. So yeah, for every dependency, we check our variables. Okay. And then we return the node there, because we just set it in here. Okay. So now it should be pretty fast to actually get all the dependencies. Okay. And actually, what we can do first of all is, if we have a integrate in here, Okay. Basically, I'm trying to figure out how to do type inference with most of these because, like, for example, a position that depends on itself will be a problem unless we take advantage of the fact that it has to define its position here. So we know for a fact that we have this type. And that's true of every variable that depends on itself. It must have some initial value, and we can infer that value instead. And so that means we can also have, when we gather dependencies, so if a variable name in this, if integrate in var node, depths var name, then what to do. Concatenate var node. Okay. Okay. So what this does is, for each variable that we have, we get the node that we've already analyzed. We create the dependencies by going through that node, and then also, if we have an integrate variable, which is basically the exact same kind of node as this expression, we'll then do, we'll just add those to the dependencies as well. And so that should help with inferring types and things like that. If integrate in node dot or node, we would do basically this exact same thing. So this is oh, dot update equals what are we going to do here? We're going to ignore that for now, because that should only be in the variable itself. Okay, because this is all good. Let's let instruction equal just our code here. I'm doing too many things at once. That's my classic problem. because I'm trying to figure out where to actually check the integration, but what I need to do is not bother yet. But what we can do is, if this is true here, we know that this updates every frame, so this is where we now do let var node equal that. So we would do var node dot update equals update frame if it depends on itself, and that would also necessarily imply, well, it wouldn't necessarily imply being an inst. No, I think it does for now. So yeah, for now. So for now, self-dependent variables are always updated each frame and instance. Okay. Oh wait, no. If yeah, that's fair. So yeah, if the variable depend on itself at any point, we do that. Otherwise, we do var node here. So we're checking ourselves again. And so that should do a bunch of stuff eventually. And then for each var node and variables, what we're doing is this again. Okay. And then we do all of our code stuff here after we've flattened the code. Okay, so my main thing now is, let's skip that for now. We need to go to type check, or no, check var. Let's make sure that everything works the way that it should. Okay, any bugs yet? No bugs yet. So this should not have any dependencies, so we just go through like this. So yeah, we have no variables. Did we not do any checked expression? Hang on. That should be fine there. Oh, it's because there's a bug. Or it's because it's, yeah, it raised an error. Can't access property myPlayer dependencies is undefined. Why is that the case? We should have dependencies equals gather dependencies, and that does that. And this should, oh, because we don't, there we go. A little bit better. Concat, deps is undefined. And that's because this should actually be that. So dep unify, deps node. Oh wait, no. This is there. So yeah, we have the graph there. So this should be starting with the node here. exp node.children.reduce. If we have, so let a equal nothing, let b equal 1. So if we did a dot reduce a b a dot a dot concat b, starting with b. Okay. Let's go back to the past. When we gather our dependencies, so for varname and variables, graph varname equals dep unify. So if we have no children at all, and we have no dependencies at all, so that should mean that now we have no dependencies. If integrate in var node, otherwise we return the graph. Okay. And then for each variable here, we got our beautiful variable. Then we'll check it. If it's unchecked, so we don't have that, we do that. So for let dependencies, we have no dependencies, then we just check the expression. And when we check that, we get our length. So if we have no length, we just flatten the code, return ourselves. And so that means now we have valid code. We know the type of everything. We just return here. And then we have all of our things that are being stored properly. And then we do that. Beautiful. And now let's gather a more complicated set of dependencies, because this one actually has variables that will be used. Okay, so we got our children. Oh wait, hang on. Oh, I see. That should be fine. Because yeah, node here also has children. And then that should have no dependencies. Good. Okay. So we have nothing there. Oh, wait. Why did that not work still? I bet it's because there's no dependencies at all. Hang on. B equal exp node dot dependencies or nothing. D. Okay, reference error, concat is not defined. That's a little... Okay, that's better. And that's because we're just doing a concat c.code, whatever. I think that should be... So we want c.code concat. Now what do we want, actually? Code equal an empty list, and then what we're going to do is just code equals code concat c.code, and then that means that node code equals code concat code. Basically, all of this code is in order because the children are in order, but then at the very end, we have this code concatenate on the end because this is our instruction. And that is when we actually do... Or so we'll need a lot of logic here. Okay, so now we can pause. Because now it's actually getting as far as analyzing everything. It's just, you know, not doing anything. Then let's do like console.log var name type info. And what this will be is type. We need readable type now as a thing. Okay, return RT. Then where do we do readable type R type down here? In fact, now we just do readable type val type. Okay, so now it should be able to figure out all of our info here. Also, I drank too much coffee, and I don't feel very good. We can also pause this here. Val is not defined. That's fair, because we don't need val dot anything anymore. And we can have this paused so it doesn't run. There we go. Okay, so now we can get things like our info, and we don't need this thing here at all. Say our type info, it's a global real frame. And then let's also print dependencies. Let's skip that for now. Okay. Perfect, it's getting exactly what I want, so it depends on itself and movement and speed. Then we have our info here, so it's still not working out how to do its thing. That's okay. Where are we not adding storage at? Anywhere we don't have... Okay. What I'm going to do is storage equals... So node.update and... Oh wait, what we need is... Oh wait, hang on. I know what to do. If we have a value here... No, I can't figure this out. We're just gonna do... we just need to set everything to have its variables by default. So yeah, like everything should have something like this. I guess not the accessor itself, but the accessor code. Anything that does not use default code. Default code, default code, default code. Update storage. So this needs that. Update storage. Update storage. Okay. It was because our function calls need to know that... Okay, it was because that needed to be there. And so yeah, we don't need to know about that for now. Because yeah, we should get a little bit closer to knowing things. So like, yeah, we know, for example, our storage and update types for basically everything, and I think they're all correct. Yeah, for example, global frame, but we don't know what the actual values are. Okay. We are painfully close. So yeah, the last thing I need to do is I need to figure out how to actually unify the types here. Because I think I actually do need, like, for let I equal 0, I less than var node, or let's say node children length I plus plus. Let C equal node children I. So what we need is, let's have different functions. So function unify call. This would be I. I know what to do. We're gonna do let types equal this, and just type is going to concatenate node dot C dot type. So we know that we're going to need to unify all of these types together. So that would just be unify like function types, or like arg types. I know. We need c.parse node. Basically, just to make sure that we don't accidentally, Okay, this is what I want. Basically, we need to type check each of these nodes, so we should get... Actually, let's just get C then. Well... I'm going to say we're going to unify C like that. And we'll have like different functions for this. And this is going to be like our child node. And then let's have an index here. So basically like let xp type equal okay. we actually have to go through everything separately, so we can't do that because we have to have this code concatenated here. Okay, okay. I think I understand what I need to do now. So if we're unifying a function, that means for let I... We basically have this exact same thing here. And so let exp type equal no.ref.type. Let sv. So this should be like a subtype equal nothing. So this is going to be like scalar vector processes. Let is vector equal node.storage. No. So let function ref equal instruction 1. So this is our function reference. And soon we'll replace it with the real function reference. So we'd have like a function equal function ref. So basically, we need to like get the overload for this function. And that should be, first of all, if function ref dot overload. We need to figure out what overload we're using. And that should just be, we only have some overloads right now. Yeah, we have literally one function that's overloaded. And we have two different types of it. And what we can do is let is vector equal okay. If is vector function ref will equal let's see. This would be function ref dot overload dot no, I guess it'd be vector. Okay. Basically, we have the duet platform, and then we can get the, like, vector overload, and then we get the name of it. So that should be, if we go back to overload. We don't, it's not called function ref.name, it's called function ref.overload. Okay. So yeah, if there's an overload, we determine if it's a vector type by just getting whatever children of the expression we have. And then that should help figure out which one of it is. And that actually means... Ooh, we need a lot of overloads for strings, for example. So like if function ref... So type of ref string. We need a very similar operation here. Alright. Let is or function is vector. Node. We don't even need this. We just do unify here. Because what we'll do is we'll just set this to whichever one it is. And we should do like node.type equals function ref dot... Oh wait, we need to do that before we do our actual like function overloading? Oh wait. That should be fine. Yeah, because we just get the function ref here. And yeah, we assign that to something here, so like let's do like console.warn to do function ref. Okay. That's where that's done. And then we would do, it is a vector type if, oh god. Basically, this node here should tell us, so like c.instance or c.update. No. Okay. This is what we needed. Basically, instance variables are vector types, and that means subtype plus equals v else s. And then we'll just do if not subtype in function ref. Oh, something happened. We would do here, error, could not overload function, say compiler bug. Not overload function for type. Subtype. Node. Parse node. Okay. So basically now we should be able to figure out automatically things like which exact bytecode to call. So for example, create.s here. And we can actually have, for example... Oh wait, this one's already done. Yeah, anything that has 0 arguments, we don't need to do anything with it. So this one would already work. But for example, this one, it should now be able to figure out that this is a scalar, this is a scalar, so it can just run scalar operation. And similar thing here, where we just have a scalar and then a vector, vector, scalar, scalar, things like that. Okay, and so what we should do as well is if exp type is not equal to c.type, error, expected argument I to be of type names type received c.type. C parse node. Okay. I'm going to compact this a little bit more. Oh, yeah, and that means that before we do this, so we should have unify. Well, actually, what we can do is node.code1 equals realfunc. So basically, we take our function reference and we apply the real function to it. Okay, so let's do... let unify. Switch. Instruction. So let's just do node code 0. So for both of these, we would just do unify function break. Default, this would be, let's just have a function like unify nothing. Or, I know what to do. Error. Not implemented. Or compiler bug. So that'd be the whole node, and then unify equals just a nothing to nothing. Break. Okay. So basically what this should do is now function calls should be able to check their type, and I think that all works. We get the correct thing, except for we need to then do we actually get... hang on. Node.type equals function reference.return. There we go. That's what I needed. Oh, pause that. Okay, so it gets that far. So compiler bug, not implemented at token blah. Oh, right, because we need node parse node. Okay. So compiler bug. Let's actually do VM names node code 0. Huh? Oh, I see. There we go. So, of VM dot. Okay, that'll give us a little bit more. Huh? Oh, I see. I was thinking of Godot. Okay, we're getting a little bit more. Function ref is not identified, and that's because we have a lowercase funcref somewhere. So function ref equals instruction 1. Oh, do we actually do anything with isVector here? No. Where is that? 2001? A Space Odyssey. Oh, right there. Oh, wait. Okay. Can't access property 0 funcref.args is undefined, and that's because at unify function, we are not getting this. So what we should actually do is return here for now. Because, yeah, I just want to see most of the things existing. So here, compiler bug. Unification with call.async not implemented at token 3. VM dot... Oh, because I... Okay, so yeah. Our subtraction and our division are not yet implemented. And mysteriously, our addition and multiplication are... That's not correct. Oh, because unification of VM.array is not implemented, so it has no idea how to do whatever it's doing. I don't get it. Let's get our type info again, and I'm just going to put code as var node code. Because I can kind of read the bytecode. So yeah, for example, our sprite, if we go to sprite type info, so why is this here? Because if we go to parse node string, working text equals this, working text plus equals token type. That's not correct. TK text I. Or exp node start plus I. Okay, well that was easy. Oh, TK text. Okay, and now we're loading the image. So we're starting to get there. We have one function being successfully called right here. From the VM even. Very beautiful. That does mean that for some reason, if we did function call... So yeah, we should have the type equal to reference return. Oh, because it's not a printable name. Okay, hang on. Name type. Okay, so what it's going to be is if type of type string, this will be a rt equals system plus type. So basically, some types are these string types. And that means if we go back to this, type info, there we go. And so known is if type of type equals string, return true, because that's a fancy schmancy system type. And that means we should actually have readable type here as like this. I'd say all the way up here, even. Okay, so if type of type is that, type names that, concatenate that. So let's go back to type names. So anytime I do this, what I should be doing instead is, oh. Well, only in a few places it turns out I'm using this. I only used it in 2 places? That seems weird. That seems incorrect. I guess because I still need to do the rest of my unifying types. Yeah, because now we need to unify lists. For let I equal 0, I less than node, children, length, I plus plus. Let C equal node, children, I, if C dot type, or let's say if elem type is not equal to type dot unknown, and C dot type is not equal to elem type. Error. Started a list of print readable type elem type. So started a list of elem type, but found C dot type value C dot parse node, and then otherwise elem, so else elem type equals C dot type. And then what we do is, actually, let's call this unify array. Case vm.array unify equals unify array. Okay. So I don't think we need to do a single thing other than node type equals... Oh wait, actually, node code. So we do like let code equal this. And then, when do we... Oh wait, hang on. Code concat code. There we go. So yeah, node.type is going to equal elem type node children dot length. And also what we need here is, for example, if node code 0 dot type or equals vm dot local node dot type equals hang on, I need to figure out something here. But what I'm going to do first, so if we have no instructions, boom. Else, if node code 0 equals VM local, else if node code 0 equals VM dot read. So basically here we would do return checked node code 1 dot oh wait, no, node type equals that. And then I think we could just return here. So we're going to actually have that. Okay. Okay, so if the type of this node is not known, we will basically figure out the type from this, and then like let's do node.type equals node code 1 type. And I think that shouldn't need to be here actually at all, because I think that never happens. Like I think there's only VM locals. You know, let's just do that. If not known that, we do that, and then we flatten the code. I'll need to figure out the integration. When we check a variable, we need to do if integrate. I know what to do. Okay. Var node checked var name equals check expression var name var node integrate. Basically, I'm doing what I was describing way earlier, where I need to check the type of this value. And that is done, actually, that's done here, I just realized. So we actually don't have this, we just have this. Actually, let t2 equal this if type, or if var node.integrate not equal to checked type. I guess this would just be var node. Error. Initial value and integration. For var name have differing types versus this. And this would be readable type var node integrate type versus var node type. Oh wait, no. This is the first one. Okay. So we have a type 2 here. And actually, to make this a bit shorter, we can just do that. Oh wait, no, we can't do that because we don't no, that's fair. Yeah, we do return a value here. It's just returning the node that we've been editing the whole time, but that does help a little bit in some places. But okay, now it should be checking the type of like this versus this. Readable type is not defined because it's actually yeah, basically every instance that I have of this, it needs to be duet.readable type. Good thing we have at least one error. Can't access property type, checked node code 1 is undefined. Wait, what? Node code 1 equals node.type checked node code 1. I know. If not, or let's rename. Oh, hang on. This is not that. This is checked. Wait. Var name equals node.code1. So this should var name, or this is a name. If not loc name in checked error compiler bug could not figure type of loc name. And this would be node dot parse node. Okay. Can't access property type, checked loc name is bugged. Hmm. Maybe I just don't return the variable here? I think there are places where I don't do that. Oh yeah, you should just... Because I was treating this as a void function, but in reality I do actually want to determine some things here. Like we do want this. Okay. So now it's a little bit better. (2038). Fun fact, Linux is going to have a bunch of bugs in 2038. But okay, this is duet.readable type. Can't access property start. Node is undefined. Interesting. Two 116. I'm gonna lower the volume on my end slightly, but okay. Oh, I see. Easy. So we need here var node dot parse node. That'll be fair. Okay, right-hand side of in should be object got null. Fair enough. Okay. Expected argument 0 to be of type real, received unknown at token 50. Okay, we're getting a little bit closer. And that's probably, Oh, received real too. Okay, so it's actually correct, except for the fact that the overloads are supposed to be correct. So basically, this clamp function here. So let's see, hang on. Let's try this again. Okay, there we are. So initial value and integration per position have differing types, unknown versus 0. Okay, a little bit closer. So it's mistakenly assuming that this overloaded function is the vector type, or the scalar type. Whoops, wrong button. This one? No. This one. Okay. I muted my mic to move it as well. I always forget when I muted my mic. Like, even if it's like a span of like 2 seconds. But okay. So here we have a few things. One is that position movement speed. We have no idea what our things are. And that's because the canvas.size is still unknown. Yeah, so that's because we do not have our read. vm.read. Let's see where that is. So do we actually get the type in here? Because we should. Default code AC node acref.type. Yeah, okay. So let's go to the type info player. should be... Oh, wait, no. It's not in here. Because, it's called position. That's still bugged. Because this code, this should not be... This should be a call function. Hang on. vm.read. So yeah, because we should be calling read on this reference to get the canvas size. Oh, wait, no, we should be calling get on it, shouldn't we? Hang on. Let's go to accessor code. So yeah, basically, I need to see if this is working still. So what is our code? What is our AC? Text. Input right. Skip that. We're gonna have a lot of these for a while. Input left. Input down. And then, shocker, input up. And then we'll have our interesting things, canvas size. So I think this, we actually get a function. Yeah. Canvas size and its type. We have all this stuff we don't update ever. So that means we should call reference get 0. And so we should have our type here. Okay, it's an array of 2 values. So then what we should have is we're going to need to have the check var function. So we'll skip the rest of these. So we don't need to worry about the sprite for now. Speed, movement, position is the one that we do need to worry about. So our code should be... Our code has gone wrong by the time we get here, because this is supposed to be a variable. Hi, welcome back. Oh wait, I know what that would be. Okay, and that's because we would have when we analyze an expression that just has a function call. Wait. Oh, I see. I understand. I was forgetting how this thing works. So var node here has children, and these children are the actual code that we have. So for example, we got, okay, here we are, what I need. So we're getting an instruction called call with get 0 arguments. Okay. And then we need to do our dependencies. Our dependency position should be, I guess we ignore that for now. We just do all of our other dependencies. Oh. Okay, so we're back to position. Then we return, we do our dependency there. Good. It's going well. I'm almost... I have, like, the VM able to load files. And so now I'm trying to figure out all the rest of the, like, type checking that I need for things like the overloads and stuff like that. Pretty tricky. But I'm getting quite close. Hi, welcome back. Let's say I'm starting, or I'm almost ready to, or let's say the code is almost working now. So yeah, very little time left. Okay. Now what I can do is I can actually go through into the node. So yeah, so we're checking the position, and so that means that we have these nodes, and each of these... Oh, I see. Wait, why am I doing this first? Hang on, did I misunderstand something? Because basically, var node here... Hang on. Does this have integrate? I need to see the call stack. So when we check the var, what does the var say? So that has an integrate. Okay, so that's fair. It clamps those, and then it has the 3 arguments here. And then, so that means that we should be doing this first. Oh, but okay, I already did that. Okay, I see. So the type of this... Okay, so this is a real of type... or of 2 counts. Let's see, I'm doing well. This done, and get back to working on games. Yeah, because I'm pretty excited to be done with this. And have something that both works, but also to just get back to making game development. Okay. So var node type. So, Okay. So my big issue... When did this change? Because this var node here was supposed to have this code type here. Hang on. What am I not setting? Because basically, when we got this variable node, first of all, it didn't actually go through the code here, which it was supposed to do. Let's see. This is a... So yeah, this game is a short jam. Yeah, it's mostly language. My eyes are completely glazing over. I think what I need to do is I need to go back to function unify. Oh, I know what it is. Whenever we do a function... Wait, no. Yeah, this is supposed to say what it is. Yeah, let's go back to unify func. Don't need to check the var right now. What I need to see is things like this, so image that, great. Minus, ignore that. Minus, skip that. Why did that, huh? Nice. Yeah, my day's been pretty good. I went on a walk. Okay, so why did this not work? Did I press the wrong button? I think I just pressed the wrong button, but okay. It's getting a little bit better. Okay. So here, what it should do is if overload in function ref, which it is vector is node children 0 type, which is 8. But this isn't right. This isn't supposed to be the integ. Oh! Wait, what? Oh, okay. I think I understand now. This analysis isn't working right. Let's see. Do I often go on walks? Yeah. Basically every day. Okay, so the issue is this is not being updated properly. And that's because vm.local when we check an expression, if it has no children, if there is a known node type, otherwise, if code is vm.local, anything here? So I need to be looking for, let's go back up to here. So I need to do that, actually. So yeah, we don't need to unify there. We need to unify here. Yeah, because we need to have in checked. So checked should have position, and that should have a type of not 8, because this code here should have already been, like, evaluated. I don't get how that's happening. Because the function call should just... Oh, because it's... Okay. I'm still forgetting things. I need to overload the operators. Let's see. It's overcast here on the coast, but it's not too cold. And there's been a lot of rain recently. Okay. All of my problems are because I haven't implemented operator overloading yet. So I need to figure out how I'm going to do that. Because it needs a similar thing to these here. Where we'd basically have... Let's call it like ops. Plus, minus, times, divide. Let's see. No Christmas tree yet. We might get a small one. But okay. Here what I'm gonna have is I mean, I kind of know what I need here, which is, I know what to do. Type. We're basically going to do, like, left, vector left, vector right. So each of these operators will now have a thing here. So if vector left let's say equal duet platform op v else equal duet.platform.op s. Actually, I have a better idea than having this complicated thing here. We don't even need that string. Readable type, check expression. Here we go. Let ops equal this. Let's see, how did I eat today? I guess I've been doing pretty well. I had a pretty simple breakfast. Beans. Okay, so what I'm going to do is function find op. So right now we just have vector left, vector right. So let's say find bin op group. If vector left, return, I know what I need. Op v. I'm going to have these slightly differently, where I'm going to have it 2v. So this is now just going to be called this. To S. And then let's just have like, I guess that's fine. And then I'm going to have here as well, like 2S. So yeah, I'm going to make it so that these are a very consistent operator. And then like 2v. So yeah, admittedly, kind of clunky that they are like, I separate them like this, but that's okay. Okay, so find bin op group. And like, let's also do like const op names. Well, let's just have that up here. Op names. That'd be like plus, add, minus, subtract, times, multiply, this, divide. And actually, all of these need to be like this. And then what I'm going to do is slightly change these so that these are just going to be full names, so that way when we print out any errors, I can use the full name. And we'll also have modulo here as a... Eventually we'll have the other ones. Let's see, so how are things in the US? They're going all right for me. But okay, find bin op group. So if vector left, so let's do let outer group equal vector left v else duet dot platform ops. So technically, you could just have a function that's called op, or you could just use these manually as like opv.add or ops.add. No, it'd actually be opv.2s.add. And then let inner group equal outer group dot 2s if, or 2v if vector right, else. Oh wait, not quite. 2v else outer group dot 2s if name equal So let name equal duet op names. I'm like losing my mind on this func ref. Okay. Say let name equal duet names function ref if not name in inner group. There we are. Okay. Function v name. Return vector if v. Oh wait, no. Vector else scalar. Okay, so if not name in inner group, we will return error. Operator. This should be function ref name not valid or not found between v name vector left and v name vector right values. Okay. That took me a lot longer than it should have, but that's okay. Because now what I can do is function ref is equal to inner group name. Okay. So now we have just normal functions here. Oh, not quite. 217. There we go. And let's make sure that all the other ducks are in order. Yeah, okay. Can't access property SS. Platform op div is undefined. Oh, because, divs. So now I'm going to completely delete my test analysis. Goodbye, test analysis. That removed however many lines of code it's going to remove. Like 100.
Lighter, man. I know you're here somewhere. You said to me before, here we go, here we go, here we go.
Very close.
This next track, we're going to be releasing soon. It's a little dedication to the ladies. Yeah.
Oh wait, we're gonna do if function node.children.length equals 2. Function ref will equal that. Okay. So if no children group, function reference equals find bin op group. We need to figure out if the children are vectors or not. So that would just be like let t equal, or no. Don't we have an is vector function, or do we not? I guess we don't. Function is vector node. Return node.type dot let's call it that. Or is vector value. Okay, so is vector... Is vector value node dot children 0? There we go. Okay, let's skip that. Pause that. Getting closer, I think. Receive real to a token blah. So let's go to position. So our type should not be... Oh, I guess it is an array of real. Okay. I guess that's fine. Okay, so what we need to do is we need to unify these types. So let's do like type equals. So anytime we do this with our actual values, we need to now like properly set the thing here. So yeah, we need like function compatible. Oh wait, we have this up here. So return type equals unknown, or type 2 equals unknown, or type 1 equals 2. Let's do if type, so array dot is array type 1 and array dot is array type 2. If not unify, type 1 0, type 2 0, return false. Basically, we need to have vector types can unify with vectors of a different length. So long as its length hasn't been specified yet. Okay. And so what we would do here is if type 1.length equals 1 and type 2 length is equal to type 1.push type 2 1 return true. Else if 2 1 else return if type 1.length equals 2 and type 2.length equals 2, return type 1 1 equals type 2 1 else, and then we can just return through here. Okay. So basically all of this to say we're actually going to set the types here. And then if there's like, so basically there's three scenarios. We have a type that has no specified length, so it could be any length, and we have a type that has a specified length. So that means that this type must abide by this type's length. And then we have basically the opposite. If this value has no type, we'd put that there. And then we have, if they both already have a length, they must be the same length. And also, yeah, we'll do that. We'll ignore that for now. So what's happening now? Received real 2 at token blah. So I want to get the, hang on. So, I guess we don't need that yet. Function ref. So I'm gonna go here. So what is our expected type? What is our node exactly? So we have an unknown variable here. Oh wait, but that's obvious because we don't know the type of it yet. Okay, so this is getting our node, and we should have a divide function somewhere in here with our function ref. Okay, yeah. We have scalars, which are not set up properly because it should not be... Oh, it should be because it's a vector. Yeah, because we have our is vector here. Yeah, so we take arrays of any type, and then that should be exp type is not equal here. Okay, so this is incorrect, because now what we need is unify. So if not unify, exp type function ref, or c.type. Okay, and that means that also printable type here, so if array, we will rt equals array. Let's call it this. So that way I can actually tell the difference, because I keep thinking that it's just a real, but it's actually an array of real values. Let's call it that, actually. Well, no, I prefer this. Okay. What happened now? Too much recursion. Oh, unify func is no longer... So wait, why would unify func be recursive, though? Oh, because we call a unify... Okay, because unify should be unify values here. Let's call this unify children. Okay, so now I'm going to try a little bit harder. So, expected argument of 1 to be array real 2, received real at token blah. Okay. So it's getting a little bit better. The weird thing is the fact that it should have... Can we get the name of the function here? How would we do that? Let's let function name. Okay. And so function name. Oh wait, and then here we'll turn no, because we're gonna need else. So operator function ref name should have. I I guess this is going to be name here. Well, I'm going to call this... I want a let full name equal so be function ref and name, and so we can actually have this will now be full name. So operator that could not be found. Let's have that. So we actually don't even need this at all. So operator function name expected two arguments. Got that many. Okay, right hand side of in should be that. Okay, so we're getting closer. Expected argument of type real at token that. Function. Function name. Expected that of... Okay. And so what we'll do is otherwise. Let's call it that. Else. Function name equals... I guess just... name? I guess just function reference for now. Or, I think what I would do is node parse node children. I'm trying to figure out how to actually get the correct function. I'm just going to do that for now. So function undefined. Expected argument want it to be of type real. Received real 2 at token that. Initial value and integration for position have differing types. Unknown versus real. So let results equals that, and then let's do if integrates in var node my life is falling apart. Okay, so now we can do this and we get an integration. And so this... So we can see here, it's deducing that this is a real value, not a vector. And that's because it's not getting this value. Because the big issue, first of all, is that it has no idea. Like, it's just not type checking the, hang on. Check var. So checked var name equals checked expression var var node. And so I really want a position here. So what I'm going to look for is I'm going to look for division. Or no. Op. Bin op group. I think I need to figure this out. So false and false. What is our function ref? Don't need that. Function ref. Don't need that. Okay, here's where we need this. So both of them are vectors. Okay. Divide, inner group. So return inner group name. Okay. So we're getting the correct division function. And then we returned null here. Wait, what? Oh. Because that's not supposed to be there. Okay. That was my issue. That doesn't... Wait, we don't even need to do anything here, because... Well, I guess we do. Okay, the whole problem, I'm pretty sure, was the fact that that wasn't working there. Or that I wasn't properly setting that there. Okay, because now it loads the image. And if we go back to the console, we're getting a little bit. Function, divide, expected argument 1 to be of type array real, received real. Function star, multiply, expected argument 1 to be of type array real, received real. So, initial value and integration for position have differing types. Oh, right, and these need to be, if not unify, var node.type, t2.type. Okay, element type is type unknown, and C type is not equal to element type. Started a list of blank but done. Let's just do if not unify. Element type, C.type. That's another one again there. Actually, I can literally just look for readable type. Because anywhere that I use readable type, I'm almost certainly trying to unify them. Okay, I think that is most of them. So now it should be a little bit better. Okay. So now we're getting a little bit closer. So the one thing that's causing issues is this division is expecting something to be of a type real 2. But it's actually of real. And that's because this is the second argument, not the first one. So why is it, why is that an issue, though? Hang on. Let's go to position. Because if we go to the code, So we get a value, and then this is a constant too. And then we call get again. Then we call... No, this is a constant too, again. Then we call division. So this is op VV. Is vector value. I bet you what it is something simple. Like that. Okay, we're much closer, I think. Expected one to be of type array real too, but was not. Well... Hang on. Find bin out group, again. Okay, so this should be false. Okay, that's good. And then if we have a vector right, it should be 2s. Okay, so our inner group is add. So we have these op vs, op sv. Huh. Oh yeah, but these are like internal. So if we have arguments here. Ah. I know what it is. It's because these now actually do need, so our binary generators need their like type 1 op, type 2 equal undefined. If not, or if type 2, actually let's just have this be type dot unknown. Type 2 equal type 1. And this will be type 1. No, then we also need return. Okay. Okay. For a lot of these, we actually now need, for example, for adding a value, type, oh wait, no, to scalar, it's exactly as it is. However, to vector, we actually do, for starters, this should be a scalar here. And what we do is type.real, type.real. And in fact, we can typically... No, we can't typically. I was about to say we can usually generate the value or the result from the right-hand argument, but not really. But okay. This is what I need. I needed to specify that the right-hand argument for these values is a vector, or it's an array type. Why is it doing that? That's not what I wanted to do. Tab completion. I never ever want tab completion after punctuation. That's this is, why would it do this? Like, look at this. That's deranged. Okay, I don't care. Basically, the whole point is I need, so here we have to vector. To scalar, what we do is we have the right-hand side here. And then we do not have the ability to clamp arguments of all vectors to a thing, so that's what we need there. This would have been a lot easier if I didn't add operator overloading based on vectors, but that's okay. Type is not defined in BinGen, because this should be type 1. Look at that. All the functions load. And now all we need to do is figure out why the code isn't there. So that is the image. Or no, that is 549.
Yo, Copenhagen, Tak, thank you for coming.
Or let v in type.values. Type this and promise. I know. If type.values, let's just do if not type.values. V. Right hand side of in should be an object got null. So if this is object and it's that. Okay. We have gotten closer. Now all I need to do is figure out if the raw sprite is running. Not quite. So let's check out duet entities. Okay. I see. My game hasn't created anything. For some reason. So it should have, though, because when we compute, yeah, we do my player create. Oh wait, hang on. Oh, I see, okay. Yeah, we get one player, and it should, we do want a reference to it, and then we call that with 3 arguments. So this should have been called. Let's make sure that that's being called. Creates. Okay, so that's being called there. So we should have in here creating 1 instances of player. ET equals this, so our count should be there. If count is equal to 1, return get ref start ID. Okay. And that should set our value here to whatever eval was. So if we go to... So type in duet.entities. Okay, yeah. We're allocating all of our types here. Wait, what? Seems like... Promise.then. Oh. Oh, because, wait, what the hell is this supposed to be? So, promises waiting dot push. Let promise equal fn args. Wait, hang on, where is this? 461, promise. Let's go to call async. Yeah, we're getting close. We're getting very close. I can almost taste it. So yeah, create a player, and then we need to allocate the player object. Okay. So we are getting a function. So if path.that, return that. Oh, I see, because because it's already loaded. So let's do... if then in promise else we can just do stack.push I mean, really what I should probably do is just have it always return a promise, but I don't care that much. We'll just return the value. That'll be easy for me. And let's go to draw sprite, because there is the bug frame. Hang on, let's pause that. Let's do duet.platform time frame. Okay, so we've gone 400 frames. Duet entities. So we have how many players do we have? We have no players, 0 players. But we should have created an instance of player. What does this mean exactly? I'm trying to figure out. So we called creation. So to create. So we should have done like val plus equals type.to create or type.count. So yeah, we're supposed to do that. And yeah, anything that is updated at this point, we actually need to do for v in values if it's an array. Wait, hang on. To create. I'll figure out. Okay, I think that was probably the issue because. So running the frame. Oh wait, do I just not run? I don't think I actually run the frame process. Hang on. Oh yeah, I never actually put this part in here. Wait, no I did. Wait, what is this? Why isn't this working? Wait, what? For type name in duet.entities, type equals this. We don't need that. Let val of type.compute.frame, val name equals this. Hang on. Type.compute. So I'm going to go through all of these. Type.frame. Isn't there also type.compute? Allocation. Okay. That's because that's down here. Entity compute allocation. Yeah.
This is where it gets interesting. This is
When do we do allocate? Okay, we do that just immediately when we run. Okay. I'm going to go through all of our allocations, all of our creations. So we create a game, or we're allocating the space for the game. Great. Then we allocate the player. Great. Then what we need to do is we are creating a, let's see what we're creating exactly. We are creating the player. And so we've loaded our sprite as well. Val equals init. Oh wait, hang on. Start should equal... This should equal count. And then it should set all those. Okay, but console.log creation type name val name type.values val name. Okay. And so now we have one object, and in values we should have one position at 400 by 300 pixels. And then for each frame, val name equals val0, value equals type name val1. We're getting an array of undefined and undefined, so that's not quite right. So, okay, that probably helps to explain that. And our position stays the same. Which is strange because it should have been undefined if this is undefined. But okay. Oh yeah, we don't even have the events yet. I just realized we're not processing events. All that work that I did computing all this stuff. Okay. What I'm going to do is I'm going to say get status type checking the bindings. Yeah, because once we do all that analysis there, then what we need to do is, so if node type equals that, if node type equals event, advanced conditions not implemented yet, so events name equals nothing. If not name in events, events.name equals that. Events name dot push. Let event code equal nothing, and then for let line of No, I know what to do. Okay. So we analyze an expression of a type. So this will be analyzing... do we ever use var name anywhere? I guess not. But okay. So first off, we analyze the expression at this point. So that's going to be node children I. And this would be, I guess, just name. Type check line. And I guess this would be name line, or no, check expression. Okay. And then what I can do is event code equals event code dot cat line code. I think that should do it, because then I can do event code. And then when we actually print things, I should do console log event name event code. Not a valid expression frame. Uncaught, can't do that. Checked before initialization. Declaration checked before initialization. Oh, that's because we shouldn't do this until much later. Yeah, because then we gathered the dependencies. Okay. I see what I'm going to do. I'm going to do let events... Okay, hang on. I'm going to just do events name dot push node dot children 1. Basically, we analyze... Actually, we can still analyze the expression. Okay. Okay. So I'm still actually going to do this part. We're just not going to do the checking here, because we're just going to have event name dot push we'll just get all of these. Okay. And then what I'm going to do is, after we check all of the variables, so we have after printable expression, so for let var in variables, and then for let var name, or let event name in events, for let exp of event name How do we actually do... I think all events here, we just run them one at a time. Or I should say, we run all events on a given thing, like, as one big block of code. So we're going to do let line of events let event code equal nothing here. Because, okay, we're gonna do entity.events event name equals event code. I think that's what I do for that. If we go back to my events here, okay, we have a little bit of a difference, which is we actually have a do here. So yeah, for now, we don't have any conditions.
Sometimes it goes left, sometimes it goes right, sometimes it goes backwards, sometimes it goes forwards. But
okay, because that means, yeah, this is just one line here. Let's see if that does what it's supposed to do. Can't access property push. Event's name is undefined. It should be not undefined because we set it to something. If not name an event, event name equals this. Yeah, we have an empty thing. So our name is in events. What? Oh. I love JavaScript's operator precedence. That's another thing that I love about it. I love that in takes higher precedence than the not. So you can't just do not in thing. You have to do it, you have to wrap it in parentheses. I think that's a great feature. And you're telling me this language was only designed in a week? That's crazy. So was mine. And it's even worse. But okay, 1947 check, loc_name.type. What the hell is loc_name? Oh, I see. Compiler bug could not determine type of loc_name. Not a valid expression frame. I think that's going to be the most important thing here. No, I don't get it. Hang on. I think that's basically, because the player here, this frame is here. Where the heck would that be? Oh, this is, no, that's correct. And for let I equal 1, node children length. So I think what I need to do is parse node.event here. So yeah, our condition should be nothing. Yeah. So our name is frame. If our name is not in the events, okay, so we have an event called frame. And then for each node children, so we should just get one child here. So we have, that's not the right thing. Hang on, let's go back up. That's literally not the thing that was here. Oh, because okay. I forgot there's no variable name there. That's only in a check expression. Yeah, here we do the event name, and this should be that. Okay. So now, almost, checked loc name is undefined. And that's, again, because of that. Actually, we can just have... I have a great idea. Just have it go the opposite way. Hang on, my mouse is gone. How does it even happen? Okay. Try to call a variable like a function at token blah. So that should be probably, if we pause this and then run this. Okay. Canvas, draw sprite. And that's because we need to do tk text. That would be a, so tried to call a variable like a function, a token, oh wait, hang on. Events, event name. For now, I'm actually just going to do this. So basically, this is all of the code that's unconditional. Okay, so this is the issue where we are now getting AC or successor. I want it to be case insensitive. Okay. So tk text here should be fine. So let's say try to call a variable like a function. Let's do... name.text.join. Oh wait, hang on. Tried to call a variable. Like a function. There we go. Okay. Tried to call variable canvas.drawSprite like a function. And that's because this needs type function. It would have args, would be image, and then vec2, no, wheel2, and then return void okay. Can't access the lexical version of that. Real is not defined because that is at 262. Ah. Beautiful. So now it's at least telling me, like, types that are properly working, of, like, it recognizes that this is not a function that it could find. Ah, and we need a scalar position here, which isn't correct. Because, this position here is supposed to be a, vector, or, like, the, Hang on. I know what to do. vm.local. So if this is here, we actually need to do node dot storage equals math.max. Let L equal this. Type max L dot storage update. Okay. So now what it should do, it's getting closer. Now we get inside the instruction. So what is this one?
Blessings, Copenhagen.
There we go. Okay.
Much love. Get home safe. Respect. Bless.
So here we have A's, which should be... Okay. It's not quite right, because it's supposed to be, again, a list of values. So let's go back up to instruction. .args. What? Oh, because, yeah, again, this is supposed to be an array of length 1. And that's because code here. So we are doing op vs a's b's. Why are we doing op vs? Hang on. Who are we? Oh, wait, no, this is completely correct. That's completely fine. Why is my mouse gone again? Okay, here, though, we have a definite issue. That's with our mouth, what have yous. Hang on. Input. I think that's input. Yeah, because what is our instruction? So this is at the function, whatever this is. Our arguments are undefined. That's all the way up at eval, where we're doing player code here. And that's getting the movement. And then it does all of our other stuff. Okay, well that's not important right now. A's is a nan. So what happened now? In promise, invalid array length. Function, so op vs. Let's just do if not array is array A's. So what is A? So why is A? Who are we? Where are we coming from? So we're evaluating the code for the player again. So we get the player's position, we get the player's movement speed. And then we are calling on... Let's see, so our pointer is 26. So our instruction... So we have gotten down to here. So this is calling VS on AS. What is our stack? So the top of the stack... No, the bottom of the stack is here. So this is our top, quote-unquote, of the stack. So it's 2 values. And our arguments are the number 10 and nan and nan. Is that because I'm pushing the arguments in the wrong order? Because what I could do, actually, is just swap around the structure here. I think it might be... Hang on. What I'm going to do is I'm going to let args equal... Slice, let's do minus, no, we would do, hang on. So slice has a length, no, this is the index, okay, slice, I have a good idea. To simplify my life, first of all, this should be here, and then let result equal this. If instruction type, or instruction is equal to vm.call async, and there's then in the promise, we do that. Otherwise, we push the value here. And here we'd have results, results, results. Then we don't need that at all. And then what we do is we are going to let start equal stack minus args.length minus 1. And then args or no, let's let a len equal arg2 So if we did 1 and 1, for example. 2, 3. Wait, hang on. I don't get it. I think I do get it. So if we go 0 to 2, okay. So this is basically start and start plus length. Let's make sure that that actually works. So if we did a is equal to like 1, 2, 3, 4 here. So like if we did 1 to 2 to 3, 4. Okay. Oh wait, actually that means that we don't even need this because we just do that and then we do stack.length minus length. Hmm. I think for things like unifying functions, the main thing that we do is... I think we take the code and we concat it here. Got keyword case, expected expression 463. Oh, wait. There we go. Pause that, go to player. So I need to figure out args. Oh, wait, hang on. 449. Can't access property count, ET is undefined, so that is at 356. Entities type name. Creating 1 instances of true. Oh, that's because CTOR. Basically, I've now swapped the order in which these operate. Okay, ID is undefined, so that is getting a little bit better. Oh. I think this is actually results. No, wait, no. That's fine. Basically, we get the number of waiting promises, and then we add one of them here. Can't access property 0, as is undefined. Or A's is undefined. Okay, that was kind of dumb to do that, where I, like, reorganized everything immediately. But, you know, function. So if we unify an array as well, I think I should do the same thing here, where basically, well, I guess that's fine as it is. I think that's going to be vm.array. Wait, do we actually... We don't concatenate the code here. Wait, that explains why that was... Okay. Code equals c.code.concat code. Okay, so that explains why that was undefined, at least. So yeah, we're creating a player position there. So we have a lot of stuff that's starting to work. But yeah, opvvv, ranger, invalid array length in opvvs. Okay. Or VSS. And there's only one thing that is VSS here, which is a clamp function. So what are we clamping? We're clamping 0 to 0 and C. So this is mixed up, because now what we do is subtype is actually in the opposite order. So subtype equals this plus subtype. because we're not VSS, we're SVV. I think. No, we're SSV. Wait, what the hell are we? I think we're just calling this in the opposite order. Okay, who is this coming from? Hang on, let's go back to instruction. Arguments. Okay, so I'm seeing some things here, which are, first of all, we actually need to start at the, What is our length? So our length is 3, but we have 4 objects here. Stack.length minus length minus 1. So I guess here stack.length minus length? Hang on, because if I did like a 1, 2, 3, 4 slice a dot length minus 1 I don't get it? Okay. Well, that does what I want. I was off by 1 there. Can't access property count. ET is undefined. Okay. Could not overload function of type S at token blah. So do we have the function name anywhere? Okay, could not overload subtract for type S. I disagree. I think we can overload functions for type S. Oh, wait. Okay. Can't access property count. ET is undefined. And that's because this type name here. Okay. So what is our type name? So type name true, count, refer. Okay, so I think that means that whenever I did that, this here should not have been there. So type name, count. I don't know how that works, but it works. Okay, so this is supposed to be that, and that is now happening incorrectly because c.code.concat. This is still incorrect. I don't know how anything works. I think it's because I just don't understand vectors. Oh no, I don't understand my stack machine here. Okay. It feels like no matter what I'm doing, It's wrong in one of the ways. So does our instruction here. What is our code here? So our arguments are these. So what if we just reverse these? Stack.slice.reverse. Let's just keep flipping things around until it works. Did it work? No. No, because that's also opposite. Oh, God. Slice. So yeah, now I really hope I can get the last of, or basically just get a thing moving. And if I get it moving, that'll be good enough for today, because I can make a cool video game tomorrow in this, which admittedly is unfortunate for you, because that means that you won't get to see me write code for the game, but I'm probably not going to do anything very impressive. Because yeah, it seems like I just don't understand what order the arguments have to be in. So our length, we have 3 arguments. We got 3 arguments, so true, 1 player. So... wait, why the fuck is... Sublime text? Is it in here? Okay. It was because this was out of date. Okay, so our length is that. So yeah, we got player 1 true. Okay. And then we're going to do that again. So we're going to get 1 argument. And it's going to be this asset. Why is that twice on the asset? Or twice on the stack? Why was that on the stack twice? Do we push to the stack twice by default? Or by accident somehow? If we did a constant here? Huh. I don't really care, to be honest. No arguments. You know what, let's actually do that. What's the button I can press to go fast? F8? Okay. We got 2 arguments now. One is a list, and one is a thing. So the big issue is that this was supposed to be a scalar, or this was supposed to be a list. Okay, so I definitely see that the stack is putting things twice. That feels like it's because the code is duplicated twice? No. Yeah, because we get... Oh, wait, no, it is duplicated. What the hell? XP node. Our unify... So, concat. Unify array. Unify children, unify function, unify code equals code.concat node code. Ah, I double it by accident. Okay, so that's part of the issue, or that's a bug at least. We were just calling all code twice. But yeah, so now we actually have like more reasonable things on the stack. And then it would not call it twice. Yeah, we can see there. Okay, so now I'm not seeing as many errors, hopefully. We're also not doing anything crazy yet. What is our stack right now? 0, 0, and 400, 300. Okay, now we got big things ahead of us. Well, in the future, eventually, once we get this. So we're doing something with this in length. We're multiplying it. That's what we're doing. Because then what we're going to do is we're going to take our arguments and our thing again. Why did it push that? Push. Oh, and here we're also going to do the same thing. Let result equal stack dot slice arg. Oh, that probably explains it. The stack isn't actually being shrunk there. And so here we would do... I guess we just do it in the same order. So we actually, yeah, so we don't need to reverse anything. And then, okay. And then we can pause, and then I'm going to assume and hope that everything works. Yeah, because basically the stack was getting all messed up because we weren't properly doing things. And here again, we get that. Great. So why is the thing not working? Invalid array length instruction. Oh, wait. Okay, wait, hang on. My things are... I'm like going crazy, basically. Okay. So we have, at the very least, almost everything works, except for this, again. 468, stacked up link. Oh, wait, because this... No, that doesn't make any sense. Okay, so our length, so our stack is 2 values. Our length is undefined, which is cool. I like that. Why the hell is that happening? Because this is supposed to be argument 1, and I'm dumb. Okay. Now we get the correct thing. We get our result. The stack is smaller. And then we add the thing. And then I'm going to completely ignore anything that is not our thing. Okay. Now, is there any hope of this being executed? No. So let's go through each of these. Because basically frame should have events. Okay, so we have one, but it has nothing in it. So event code here is a list, and then for let line of events, event name. Entity, events, event name, check event. Oh. Wait, no, that should be fine. Hang on. Well, actually, we will have, so for each event, we'll do that. Okay. So I need to figure out, so what is this line? This has code. It does its code. So that should be calling this here. So code here, why is this not working? Oh, because it's still, yeah, because we still need this. Okay, so I'm just going to assume and hope that that is set properly. So if we go back to code, yeah, we get one sprite, one position, then we call this with the image and the positions. And so event code should be equal to our line code concatenated with that. What? Why is that 0? Huh? Oh. I hate being alive. What can I say? I suffer immensely. But okay, now we can do the code. Yay. I win. I made a thing that turns into video games. And then what I can do is I can do my player 2. And this would be awesome, even though you can't see anything here, because there's just going to be 2 of them. Oh wait, hang on. Does it move twice as fast with each one of these that I do? Hang on. Let's first off check that. Variable already exists. I think each time I do this, the movement, I think each player is in here together. But okay, yeah. Important things that I need to change are the ability to set constructions or set properties for different things. Wait, hang on. Now it feels like this is just moving faster. Is it just moving faster every frame? What is happening? Hang on. Oh, I know what it is. No, wait, no. That should be fine, yeah. Because when we compile and run, we clear the entities here. Yeah, and then we do entities type name equals D. Interesting. Well, okay. Let's start making some things. Because now we got... We are at square one. So now we need to just make a video game. And so what I'm going to do is, like, input. This should have a mouse position. Type is type dot real. No. A vector of 2 real values. This updates every frame. And get. JavaScript mouse relative position. And then let's also get a crosshair. So I'm going to do like 16 by 16. So yeah, we'll have a crosshair that the player aims at. We'll have the player rotate toward the crosshair. So this should be assets crosshair.pdn. No, png. And that will be awesome. Basically, it'll be page X property of the mouse event interface returns the X horizontal coordinate in pixels at which the mouse was clicked relative to the thing. So yeah, let's do this. Every single time. So, as I didn't find a jQuery free answer... So document, get element by ID, click me, on click function. This... I don't need that. I need mouse, like, just the position of the mouse at all times. Oh, whoops. Okay. Mouse move is what we need. So... key down. Duet. Canvas.mouse move equals duet.mouse move. E. So I'll just do mouse move. Okay, I guess what I can just do is have a document event listener here. No, mouse move. So yeah, let's just do document.add event listener. With that mouse move, and this will be done somewhere else. Probably here. And so when we do mouse move, that is going to set our platform input mouse value. And that should set it to the element position. Let's do let key equal events. So event client X, event client Y. I want to get the position of an element, JS get position of element, highlighting elements under mouse. Okay, let's see if this actually document element from point, that. Element is that, okay. So we can get the element from the point, but I want to actually have the relative position. Okay, I'm going to do page X and page Y. Because that gets us the absolute position. Or let's do rel, and what I'm going to do is have like let... So, HTML element position on page. Or coordinates. Okay, element.get bounding client rect. R equal duet.canvas.get bounding. I want the bounding page rectangle, I think. Because I think this is going to return, so it contains the entire element, the left, top, right, blah, blah, width and height. So properties other than width, and, so this should be... Okay. So is there a get bounding? Okay, so it's just the client X. If you need the bounding rectangle relative to the top left corner of the document, just add the current scrolling position to the top and left properties. Well, okay, then we don't really need this. We can just do client. Get bounding client rectangle. And what we will do is we will subtract r.x and r.y. And this will be duet platform dot mouse dot value equals that. And so now what I want is I want to figure out, I can't actually do, for example, this, hang on, let's do crosshair. Oh, control enter doesn't work, right. Right, and right now, it completely murders the page. Hang on. Close that. Kill it completely. What I want to do is I want to figure out event. So I think it's going to be in parse. Oh, offset XY. Okay. That makes sense. Okay, so new node, that. And I guess what I'll do right now, so we have a condition. So our condition is just the name of the thing. So we need to grab a new line, we need to skip ignored, grab indentation. Then we do our things here. Oh wait, hang on. Oh wait, no, this should be fine. Okay, so if there's no function, that means that we have no messages. Otherwise, while function, we add that to here, and then we skip ignored, which is fine. And then we should grab that. So we did not grab a new line, or we did not grab an indentation. Well, we should have. Okay, but that seems like it should have done something. Okay, so our condition has no things here, if not condition. Wait, what the heck? What are we doing here that's not working? So if not condition, or can it like reload without like killing my entire mouse? Okay. But now we should be able to get that just fine. Everything works there. We don't need to deal with the files at all. How are there so many things that have breakpoints? I do not remember them at all. But okay, it does seem like every time I load the file, it gets faster. Yeah, every single time oh, because it's adding more timeouts, I bet. Okay, it's because it's just running more frames every frame. Wait, no, that doesn't make any sense. I guess it could make sense. Because, yeah, we don't actually cancel the other things. So let's just do, like, paused. I don't know how things work. I need to double check how set timeout works. Set timeout interface sets a timer which executes a function or specified piece of code once the timer expires. Okay, so yeah, it's not repeating, but that does mean that I need some sort of way to make sure that there's no frame that's currently happening. You know what, I'll just pause the game. And then you have to manually, like, reactivate it. And that means also when we go to here, set paused, so toggle pause. Okay, so now hopefully it should work consistently. So like every time I do this. Okay, that was it. Basically, because they were getting off sync, there was just more and more timeouts for this paused, for this function. Yeah, now it'll pause itself automatically. Which doesn't actually fix my main issue, which is the fact that I need the ability to... let's update our code. Because what I want is let okay, first off, assets sprite, no, crosshair PNG. So every frame we do canvas.draw sprite crosshair position, and this will actually be input.mouse. And so, yeah, the thing that I need to figure out is, does this work? Okay, that seems fine. So condition, so here now, okay, so now at least it doesn't crash. Yeah, so it doesn't know how to handle the parsing here. Can't access value. Duet.platform.mouse is undefined. Oh, because it's, wait, what? Can't access property value. Duet.platform.mouse is undefined. Oh, because that's an actual bug, not a Duet bug. And this is because this is input.mouse. But okay. Now, at the very, very least, we have that there. And that is currently not updating properly. And let's remove a lot of console logging. Well, the promises are fine. Removed, compiling, dependencies. So yeah, a lot of these. Yeah, because we don't need so much stuff. Expected to value at token 96, so 784. Oh, wait. I wish I had figured out. So that's from parsing. Remaining code not parsed. So expected a value. So while it's good, grab duet operator. So what is... So where are we? I'm assuming we're inside an event. Okay, what I'm going to do is I'm going to try to figure out messages. Because this is, like, not necessary here. So yeah, if we don't grab that, so I'm going to go here. So yeah, we need to get indentation, so skip ignored. So what are our tokens? I need to figure out what tokens we've got now. Event, I need to go all the way to the start of our list. Wait, hang on. A message is a duet parse call. So if name, otherwise we get that. Okay. Okay. So we got a function. Great. Otherwise, well, function, we add the function here. Then we skip ignored, which actually means new lines. Okay, okay, I see. So what we actually need to do is we need to grab this first. Okay, I think that helps. Okay, okay. So now, if we resume, we don't have our, hang on, let's go to draw sprite. So what images do we got? Got assets player. Got assets player again. Where's our eval? So we should get this. Okay, okay. I see. It's not being properly processed. Because yeah, we get the sprite and then the position, then we put that there. Then we get the crosshair, but yeah, we don't get this properly again. Why would that happen? Event. I know why. Because I probably don't do my, oh, I see. Hang on. When you go to debugger, we need to go to analyze expression. Or, events. Okay. I need to figure out what the actual thing looks like here. So our node has 3 children. And yeah, that looks correct because we, for each of these... Wait, hang on. No, I don't get it. Because... Yeah, I don't get it. Hang on. We need to have console log event. Printable, what would it be called? Like a readable var? Printable expression. And that should do all of this stuff with the code and stuff. So... Show parse results. Is there like a readable node here? Oh, it's readable tree. Printable tree? Okay, it's printable tree. And so what I'm going to do is I'm going to go to parse node.event. And this would be node. Oh, no, this would be tree. No, I think it would be node. Okay. Access property type. Tree is undefined. Oh, because we need the whole file. So we need file here. I think that's somewhere up here. These functions are so long. I don't know anything. I don't know anything about anyone. Okay. Now we can get here. And now we can see what the actual event looks like. Okay. So we have, it's exactly as I expected, where the first object is the condition, and then each following object is a function call. And those have their things here. Okay. Good. And so that means that we should have here. So yeah, we add the names there, and then we're going to do events name, events name. And so somewhere in this mess, are we returning from something? Wait, what? There's so many, hang on. I'm going to remove all of my things except for this one. So hang on, I need to figure out where events are. Okay, so we have 2 codes here. Okay. And I think what I need to do is, when we check here, so we don't need that. Overloaded. Printable expression, event name in events. Okay. I think this is the issue. I think let line of. This is not correct. For let I equal 0, I less than events name dot length I plus plus. Let line equal event name I. Because yeah, it seems like something is going awry with our events. So let line equal that. So this should be, once it's checked, now it's correct. Okay, so we have our image, we have our sprite that's being drawn to a position. Good. And then what we should have is another expression. And this. Oh, wait, no. This line, it should have done something. It should have gotten this. Why did it not get that? Is it because I never properly set up the functions when you call them? I think it might be. Is there any message about the issue here? Hang on. Oh, wait, no. We need to go into here. We need to figure out exactly what our instructions are. So this instruction is incorrect. because it knows that it has arguments. But what really confuses me is why does it make sense? Oh wait, hang on. No, okay. I was wondering if it was something like I was concatenating the code at the wrong time, but that feels completely correct. Okay. So for node children, so we have 2 children here. I think the big issue is that this code is wrong. Yeah. This code isn't supposed to be doing this. It's not supposed to have nested functions yet. And that's because we are... Oh... Wait, no. That's perfectly fine. This is supposed to be what it does, where it adds the line code, specifically the code. What's happening is earlier on, when we do the... Okay, I think what it is somewhere I'm doing the code wrong. Analyze expression. One of these is incorrect, I'm pretty sure. I bet you it's an accessor code. I think that's fine. The constructor, the function name, and that should call ac.ref. That's correct, I think. Is there... So when we read acref, that's fine. This is fine as well. Wait, actually, I'll say that that's exactly what it should be. Okay. So I think function calls might somehow have some way of going incorrect. But no, that doesn't make any sense. So yeah, let's check what the events look like again. So the code for both of these seem to be malformed because... Oh wait, no. No, okay. These are fine. That is correct. Because basically this is a function reference that needs to be detected and then overloaded. And so the problem is, when we check this... So we've checked line 1. So the code should now be this, good. The event code is now this, good. So now the line here, this function is not being fixed. This overload isn't being properly detected for some reason. So there's some place, somewhere, where our real function is not being... So real function... Okay, I see what to do. Okay, node code 1 equals. So we need to figure out why this isn't happening, and that means we need to figure out why the function is not being unified. So for the first one, it actually happens correctly. So we're going to get this SV value basically going to go through our children, go through the length of them. And so we know that these have updates, so like image and what is this? Yeah, that's a type of image. This is a type of reel. And so we unify, we do all of our things correctly. And so subtype plus equals that. So we have an SV function now. So our real function equals function ref subtype. Good, good. But then the second time we do it, with the second event, for some reason it doesn't work. So function name equals function ref. So yeah, we have the same function ref now. And now we should get our things here. So we go through each argument. So again, we get another image. And actually, let's double check. So yeah, that's also a global variable. So our subtype is the same as before. Oh wait, I think I know what it is. It's because it's a mouse. And because it's a mouse, we know that there's only one sprite required. Okay. So the issue is, it doesn't know, not subtype in funcref. And so why was that not causing issues? Or why was it not told to me, I should say? Okay. Because basically the issue was, if we run this, close that, run that. Okay, it was just supposed to tell me that. Draw sprite. So now I'm actually just going to have SS image position. I think it's just the errors are not very clearly communicated. Okay, because that took me like an hour to figure out. Because I just didn't have this open and I didn't do that. And it's still not drawing the sprite function. Hang on. SS. Or like draw sprite. So we should be doing this now. Any second now. Oh wait, no. We shouldn't be doing that any second now because we need to do this. And then we can do that. And look at that. Now we have a little crosshair that we can shoot around. I want to image. Can I like invert the effects? So if we did like colors. Polar inversion? No, that's not quite what I want. Whatever. I'm just gonna do fill it with something else. Go like red. Global mode. I don't know what to do, but that's better. Yeah, global mode. Delete all of that because what I need to do is I want white pixels. This is going to be my awesome video game. Any second now, it'll be awesome. just have that like that. There we go. Whew. But now, we have all sorts of crazy and cool and wonderful things. And then what I'm going to do is I'm going to have the mouse shoot, or the mouse click. I'll figure it out later. That'll be for another game jam. So I want to do click. And this will be left and right. And these will just be, for now, type.real, value, or update frame, value 0. And so that means that we need now a click event on the canvas. Oh wait, no. Ooh. Okay, so I think I can just do canvas dot on click. So event type mouse event, button. The button's property mouse event. How do we figure out which mouse event? So like, does it tell me which button it is? So like, oh, okay, there it is. 0, 1, or 2. Do we also have like a mouse release? And I'll just do like if e dot button equals 0. That'd be duet. Platform dot input dot click left equals true. And then we have a similar thing here. And then I think what we need to do is anytime this isn't true, we would need to call input dot oh, how do we detect when a mouse is released? JS detect mouse held down. So registering mouse down and mouse up is wrong because they can happen after that. Coming after your problem, reaching this is there. Okay, so what is the better answer? Keep track of that. Mouse up will only fire when performed within the browser. However, mouse event now indicates which buttons are currently pushed. Okay, so that is actually, so a simple implementation might look like this. So E buttons. So that code tracks the state of primary mouse button So I'm just gonna do... Let's just check, like, check mouse. Events. I think what it is duet dot platform. Or let's do let m equal duet dot platform dot input dot click. M dot left equals event buttons Okay, let's look at buttons. So event buttons read-only property indicates that. Do not confuse this with button. Okay, so we'll just do event buttons and 1. M dot right equals event dot buttons and 2. 1. So that'll be shifted over. Great. And then what we can do is if what we'll do instead is if... Oh wait, hang on. Else. So on Safari, we will respect that their buttons are different, and it will be Safari's which UI event.which, no longer recommended. Okay. No button, left button, middle button, right button. For keyboard event, event.which indicates the numeric code that was pressed. I'm not gonna bother. Oh wait, I keep forgetting that, but okay. Missing a thing, and that would be 364, column blah. Oh. I don't see it. Oh, I do see it. And so I also would really like WASD here, but I want it to be like layout independent. But unfortunately, it's platform dependent to get those codes. So it's extremely difficult. Because I don't even know if you can like check if you're on Windows or like what OS it is. But okay, pause. So let's do JS layout independent keyboard, because yeah, I really would love some WASD. So JavaScript library for binding keyboard combos, simple keyboard. No, I don't want this. I want key codes. So the keyboard code represents a physical key on the keyboard. In other words, this property returns a value that isn't altered by keyboard layout or state of the modifier keys. If the input device isn't a physical keyboard but is instead a virtual keyboard or accessibility device, I don't care. What I'm going to do, let's rotate the canvas. Rotate. Oh wait, no. Canvas, draw image, rotated. Canvas is context.translate and context.rotate to rotate your image. That's crazy. Oh, also, I didn't realize it. Okay, I'm gonna also do this clear rect instead of draw. Clear color. How would I set a custom clear rect? Like, what is the difference between clear rect and draw rect? So, method erases the pixels in a rectangular area by setting them to transparent black. Be aware that clear rect may cause unintended side effects if you are not using paths properly. Make sure to call begin path before starting to draw new items after calling clear rect. What? So it starts a new path by emptying the list of subpaths? I don't care. What I'm going to do is I'm going to have a... let's go to my CSS. So, where is our game canvas? This should be a hashtag. And the background color 333. Okay. There's so many breakpoints. There's so many breakpoints. Why do I always have so many breakpoints? Is this doing something? Wait. Okay, so I do think I actually do need to do, so clear rect. This is like the most confusing API in the entire world. Wait. Okay. The fact that first of all, okay, anything here, canvas is not defined. I'm gonna die. Okay, but now at least we have this, we have resume. It does that. And then what I'm gonna do is I'm gonna rotate our freaking sprite. Draw sprite. So let's draw at an angle. Actually, let's just have an angle like, hang on. Okay, so we have radians as our angles. So what I'm gonna do is I want to have optional parameters to functions. Let's do args equals 2. And what we'll have here is also a type dot real. And that'll be like radians. Oh, I see. EXP link. Okay. Mm-hmm. Okay. If name type equals function name. Equals this. I'm gonna do some more complicated stuff here. Else that. Okay, what I'm gonna have is if required args in ref expected length equals required args. Actually, we need let min args equal. So we need min args and we need max args. Okay. Oh, wait, no, this is max args. Okay. And then we have this here, and then if args.length is, let's do greater than max args, function expects let's see, max args expects at most this many arguments, but was given that many arguments instead. Else, if args length or args.children length is less than min args, let's just say expects between min args to max args argument, but was given blank instead. Okay, so now I should be able to get any number of arguments. So function called without arguments, but expects that many arguments. That's fine. Okay. So what I should be able to do now is let's try doing let's try actually formatting this. So how the heck do we do this? Context.restore. So yeah, we do some stupid stuff with the context. So I'm just gonna do every frame, we're just gonna, no, we need to do that. Draw sprites. Duet.context 2d.context.restore. Oh god, but now we actually need I'm seeing what I need. For every additional thing here, I actually need hang on. SVV image positions angles we do for let position of positions Wait, we don't even need this in here. We can just put this out here. What I'm going to do is I'm going to figure out this. Duet, draw 2D, rotate. Let's call it that. And then what we do is duet dot platform. Draw sprite. Now where this is canvas. Dot draw sprite image positions. Oh wait, and this needs to be dot sv. Duet dot draw 2D dot This one's just going to be angles dot map a duet plan platform canvas draw svs image positions a, and then SSS image position angle. SVS SVV SSV is almost the exact same as this, but this is actually SS and this is SV. Okay. Oh wait, no, that does need to be that. There we go. Okay. So yeah, now that we can overload functions, there's a sort of combinatorial explosion of possible functions here. I should probably just not have like this it's called rank polymorphism, basically, where we have like, well, I guess now this is, yeah, it's too late now. The ship has sailed. Required args is not defined. No. Okay. Almost. Can't property restore. Oh, because it's not dot context restore, it's just dot restore. Okay. So now what I should be able to do is I should be able to draw, for example, the player at 1 radian. And it's not quite what I wanted it to be, but I think okay. This canvas API is awful. Okay, I see what it has to be now. We have to translate our object. What? This is impossible. So I want to draw a sprite at a position with a rotation. So I think what I need to do is actually we do context dot translate. Duet canvas width divided by 2, duet canvas width height divided by 2. No, we don't need to do that. We do negative position. And we actually don't even set the image at all here. We don't set any of this position stuff here. We actually need to, Then we translate back by that position, which is a horrible thing. Okay, so context, translate, negative center. I guess we just do, actually, we don't even need the center anymore. Because yeah, we translate this whole thing by that. And that means we can't actually draw here. We need to draw, I'm gonna just do angle equals 0. This is the worst moment of my entire life. This is utterly impossible to understand. Because I want to draw a bunch of images that are moved to positions and then rotated. And sometimes I have multiple locations and one image. So no need to save and restore between calls as it sets the transform rather than multiply. You know what? I'll do that. Context.set transform. Okay, so I think the reality is we just are going to have an angle here, and then it's always going to be just one angle. And so we just have like angle equals 0, angle equals 0, and then we will set our transform for each position here, context.set transform. So what is our scale? Our scale would be 1. So scale and origin. This is like the worst drawing API I've ever seen. You would think they just have like draw rectangle with scale at position. Oh, Jesus Christ, it's a matrix? Okay. Is there like just an explanation of like what the numbers mean, Mason? I feel like this is going to be what actually kills this as a possible thing that I can make. Okay, 1, 0, 0. 1 CW plus position 0 C H plus position 1. Yeah, I really should have splurged for OpenGL at this point. But okay, and that means that we don't need anything with draw image at all, because we just do that, but we're going to also context rotate angle. And so we'd actually have a similar thing here, where we just set each of these. Oh wait, no. And this needs to be... Okay. And now we don't need to do anything at all with the restoration, because we just set the transform. Okay, context 2D, draw image. 1 is not a valuable or valid argument for any overload. At 276, draw image, image. Okay. And that's because when we draw an image, dx dy, so I guess we just do 0 0 because now we don't need to worry about the context at all. Reference center is not defined, that's fine, because what we're actually going to do is just that. So yeah, now we just rotate by the transform. Okay. So now we got some funny looking results here. Probably because now we actually do need draw context 2D.restore. So I'm going to do, actually, I have a good idea. Clear rect. I'm just going to do duet.draw2D.set transform 0 0 1 0 0 1. Was that what it was? No, 1 0 0 1 0 0. Yeah, so now okay. And if we go here, we can actually set this to 1. And now look at that, beautiful. We rotate the thing to exactly where it needs to be. Isn't that wonderful? So now what I want is I want an angle that is between our ship and this thing. How would I do that? So angle between 2D vectors. So if we have this here, and we want to figure out I guess we would do this. So that means theta would be the arctangent. So theta equals arctangent of I guess the absolute value... Wait. Relative to what? Because I think it could be... It's either this one or it's this one. So it's either this angle... I think it's this angle. Opposite divided by adjacent. So that would be... and opposite divided by adjacent is equal to arctangent. Mouse dot x minus position dot x. Divided by mouse dot y divided by position dot y. And we could flip the sign somewhere in there. But that basically means that when we are drawing our sprite, we are now going to have input.mouse.x minus position.x divided by input.mouse.y minus position.y. And in fact, it might be swapped because we would actually have, yeah, we have the opposite divided by adjacent. So this would be y, this would be x. And let's just call it arctan. And that means that now I need to get the arctangent. And the arctangent can be... Let's get this as... You know what, let's just put it as ops. Okay. Arctan. So we would have bind or ungen type.real opcore. Do we have an arctangent on? I'm sure we have arctangent. Arctangent. Atan. Okay. And that would be, I guess, just like that. And so there should be an ungen. Okay, there is, good. So yeah, S is just the operator, and that is just that. And also we can have ret type equals type.unknown, and if ret type equals type.unknown, we would then do type or ret type equals type. There we are. And now the real question is, I need to figure out how I want to do indexing into arrays. Because we do not have this functionality in here yet. And I think that requires I have a better idea, at least for now. And that's going to be Do we have an operator for colons? What do I use colons for? Isn't there some sort of operator that I was doing? Oh yeah, type hints. I'll figure those out soon. But I need to use the bathroom. Okay. So what I'm doing now is I need to figure out how to index into arrays, which shouldn't be too bad because what I can do is if we go to parse node or like value, what I can do here is when we get an identifier, if grab duet token dot bracket starts So instead of doing that, we're going to do let node equal new node parse node index. That's what it's going to be called. Let args equal value list dot bracket end. If we don't grab an end bracket, expected a bracket to end the array indexing. This is name args. So it's almost exactly the same thing. Return grow node. So now what I need is when we have a phone call, we can also do index 18. So I think a lot of these I don't use anywhere. I'll keep them all around for now though. So now what I can do is I can actually just have, so input mouse 0, okay. So what would I do now? Okay, so we can see here we don't know what these indexing functions are because we don't have remaining code is not parsed at token divided by colon at token. Oh, and that's because we need, so when we operator, so operators should not include or underscore. So yeah, when we do operators, we need to have parentheses ignored, single quotes, double quotes. Catch all for like characters. So that means technically double quotes are never allowed anywhere, I'm pretty sure. Oh wait. Invalid identity escape in regular... Hang on. So 90852. I think that means we don't have this. And probably not this. Oh wait, hang on. Wait, I think this should be... Hang on. We need more advanced debugging tools. Let's bring out our cool things. Okay. Your regular expression does not match the subject string. Okay. Match a single character not present in the list below. Okay, so why is it not invalid identity escape? So Firefox break-ins. Thank you, AI tool, for that. So JavaScript expression occurs when Unicode-aware regular expression pattern contains an escape sequence that does not represent a recognized escape sequence. So what are the known escape sequences? Is it going to be like these, and then this, and then probably that? So I think it might be that. Okay, yeah. Okay. Uncaught internal error, too much. So that is because value I don't get it. Why would this value list be causing issues? Oh, do I need to grab the thing? Okay, I see. Wait, no. We literally grab it here. Oh wait, let's do else if grab. Okay. I like that the first time it does this, it just doesn't, like, the first time you click the error, it doesn't know how to, like, point you in the right direction. So it just sends you to the file. But okay. So we get the value list, peak. So if peak is not equal to end type is that. Okay. So why is that causing issues then? Okay, so this value is causing issues. So where are we? Because we're inside the expression. STK. So what is TK text? Is there a way to do like an expression? So like Firefox eval expression in debugger. Can I just use the console? You know, let's just look up Firefox debugger. I feel like I'm missing something. I don't want like a quadrillion YouTube videos of like 30 seconds long to do every single basic interaction. What is a log point? So I don't need that. I want... So is a watch expression what I want? Allows you to specify JavaScript expressions that will be reevaluated and displayed every time the debugger pauses. Okay, so we don't need that. Where is that, actually? Okay, here. Ah, I see, okay. TK text. TK. That isn't quite what it's supposed to do. Hang on. Is there any sort of yeah, why is this not doing what it's supposed to be doing? Because yeah, we should have this function TK text, which is low text token start token blah. Can we do like a TK? Oh wait, okay, I get it. It's because this needs to be tokens. TK. There we are. Why did I set it up like that? I'm almost always going to need the, like, index of the token. Well, there are probably instances where I don't. Okay, so we are looking at 1. So we got, and then we got an end bracket. Then we add those, and then we return. So it seems like it's doing fine. Okay, so we got a slash here, so we're just doing division. And then we get another parenthesis. Wait, what's the issue now? Too much recursion still. Okay. So let's see the first time. Actually, let's see what bracket start looks like. So how deep are we into the call stack already? So we're inside, so we're in an expression, in a value list of an expression, of a value list of an expression. What's the value list here? Let's also do, let's add an expression, duet dot token names and type. Okay, so parenthesis end. Yeah, so we're nested inside 2 parentheses. We have no end type here. But okay, we've got the number 1 after our bracket start thing. And so now we have another value list. So we should just get the value, like just the number 1. Yeah, we just get a number 1. Perfectly reasonable. And then we're going to get an end bracket. So we got expression, and then we do not get an operator. And then we return with that expression, which is just the number 1. And then this, so our type should be end type. So now we end because we grew the list. Good, good, good. And then we add our expression value because now we're getting operators because we're going to get the divide by position index something. So yeah, we got our operator here, which is just the minus sign, which is tiny on your screen, but that's what we're looking at. And yeah, then we get all of our things that are appropriately set up there. And so then what we should do is, once we get position again, we have our identifier. We don't have parentheses, but we do have another bracket. And that's just, again, one object. So yeah, we just got that. So yeah, why is it like going so deep into like value and expression then? Because yeah, we don't got any operators. And so our list should just be a few things. Because yeah, now we're going to a parenthesis end, which means that we end here. So that means we end there. Okay. So yeah, we're popping out of, we have like gone through some parentheses. And then there's no actually there is an operator. What is this operator? Where's otext? Uninitialized. Oh, because now, okay. We're dividing by another value here. That should be fine, because we should just subtract. So where are we in the code? We are right here. Okay. So we should just get another value now, because yeah, we have our left side operator. Oh wait. No. Did it just get bored? Did it just get bored? This isn't even what the code looks like. I'm looking at the debug errors. Okay, because it's something. Let's look at the exact line. So 1228, which is here. I see what we should do. Grab duet.token. Okay, I think that was the issue. I'm gonna assume it was the issue. Okay, a little bit better. Because now, accessor. So now what we actually want is, so we have a function name. We should also have index 4. So yeah, invalid input type. So that's 1696. Wait, what? Invalid type v is undefined. Oh wait, I moved a line. v.type here. Duet platform AC0. Oh, I have it. Unop. Or ungen. It doesn't, yeah, it just doesn't return. I'm gonna stand at my desk now. Okay, now we're getting somewhere. We have unsupported objects. Compiler bug could not determine type of undefined token blah. So now we can do not supported. Okay. Because now we do case. Thank you for that. Duet dot parse node dot this should be index, and it'll be a very small thing. So let name equal children 0. So actually, anytime we do a function call, okay. So we should just be able to get the accessor code. Yeah. Yeah. So now we let args equal trying to understand what I need to do here. If args.children.length greater than... Do I need any of this stuff in here? Okay, I see what to do. Oh wait, actually, we don't even need this. We can just do exp node children map. Oh wait, no. We actually do need to do this, because then we do, yeah, we do accessor code name concat expression node children map. I have a good idea. Okay. Oh wait, I can literally just do exp node here. Because, like, this is supposed to be an accessor. In fact, I can kind of do that, like, in all of... Oh, wait, no, I can't do that. This is the only place where I can do that. Okay, this actually is correct. And then what I'm going to do is just code is equivalent to... This is going to be duet.platform.index. So this would be an auth vector.index. And it would be exp node.children.count. Let's say that. And so our very, very fancy indexing, Op V, index. This is going to be a binary gen, because basically we get a type of real into something here. Okay. Basically, we get an array, we index it, we get an array out. And that will be done when we do op v index. And so I think now I don't need anything other than these. I guess what I'll do is update once storage global parse node exp, all this stuff. And this would be probably, I'm just going to say type.real for now. Or I guess unknown. Because it could eventually do things better than this. Basically, it'd be like a generic array type into a generic whatever type it needs to be. But yeah, for now, it just does that. Let's see if that actually works. Not quite. Expected argument 1 to be of type real. Received array real 1 at token 103. I need to figure out the exact lines that I'm at. Hang on. I want this to also be like tokens I dot title equals let's try that. Is there any sort of thing that I can do here? Because yeah, basically I want to see this thing here. Function call. Is there any sort of like I thought there'd be a, oh wait, span title. Okay. Basically, hopefully, this lets me actually see... There we go. Okay, so I should be able to see exactly which errors are causing issues. Yeah. So, function object. Expected argument of 0 to be of type real. Received array real to... No, you didn't. Oh, wait. Yes, we did. Op v index. That's because we need, okay. So we have a binary generator, it gets a return type. Okay. Okay. It's getting a little bit better, because now it knows that this should be the correct type here, but it does not know that this bad boy here I'm pushing this poor editor to its limits, but okay. Well, not really. It's like it's 100 elements. Okay. Expected argument of 1 to be of type real. Received array real 1. And that is because we're parsing this as a list, aren't we? Somewhere in here we must be doing something with, like, value list? So did we do anything with value list? Oh, wait, hang on. I see what I need to do. So what I'm going to do is, when we do an index, what I'm actually going to do is I'm going to add each of the children. They're going to be name.cat args. There we go. That's what I needed. Because basically, it was recognizing, well, I thought that's what it was doing. Received array real 1. Okay, so what is our children here? So we have 2 children. One of them is of type 7, and that is indentation. That is value list. Okay, so that is a value list. And so what I need to do is not have that. Actually, it'd be args.children. I'll just do that. Fuck it. Yeah, so now we got 2 children. One of them is the actual value. Okay. So that should make my life a little easier, because now we can actually do that. And that means I can actually do this, which means that it almost kind of works. Look at that. Now the issue is the fact that the arctangent doesn't seem to be the actual correct value. So what is this exactly? Is it because we need some sort of, like, normalization? Yeah, so I need to figure out, like, 2D rotate object to point. Or get the angle. Because, I mean, I could have sworn that, like, this angle here, you know, it was going to be opposite divided by adjacent. And we'd be golden. Is it because I need to normalize my, like, mouse x minus position x or something like that? Well, that doesn't make any sense. How would you even do that? I guess, I mean, no, that wouldn't matter because you're dividing by them. let's let the angle equal, or let's let difference equal this. And then what I'm going to do, wait a second. Okay, okay, I see the issue. There's an extra end parenthesis. Okay. Yeah, missing some parentheses there. So now we should be able to run that. Resume it. It almost works, kind of. Hang on, let's go to debugger, let's go to draw sprite. So we need to go at an angle. So okay, our angle is pi divided by 2. Why is our angle pi divided by 2 though? Is that because our input mouse and position is no longer being set properly here? Like, hang on, let's do duet.values. Oh no, duet.entities player values. Because our difference is this. Actually, I'm just going to do position minus input.mouse. And then what I'm going to do is diff. So yeah, basically that 0 divided by diff 1. Okay, so what is our angle now? Okay, now our angle is a little bit different. I think the main thing is I need to set this to be the negative arctan, or maybe we do... Right, I did say it was this way. Yeah, so I want our cool game Yeah, the really confusing part is the fact that, maybe we did like times sign, so like diff like 0 times ops, etc., etc. And so now we can start building this out with like op s dot oh. Oh, because it's ops. Hang on. Pause there. So, if, error, or like errors. Say analyze all. If result.errors.length greater than 0, duet set paused true. Yeah, so it pauses automatically now, so that way we don't have 17,000 billion things. Because if we go to here, basically what I actually need is alt sign. And there we go. And then kind of looks right. Maybe we do absolute value. Like, so, okay. So that's not right. So, try to call variable sign like function. Let's say that. So like, tried to call a variable. So let's just say unknown function. Okay, seriously, how do I just rotate sprite toward point? Let's look at the function. You know what? Let's just go to Godot. And let's just look at the function look at. Oh, wait, hang on. It's because I'm in private browsing, isn't it? So if I just did my normal browsing... Okay. Look at... Okay, let's look at get angle 2. Angle. To local p position times get scale dot angle. And so we literally just subtract our position from this, and then we do this dot angle. Okay, and then that's going to be a tan of y of x. Oh wait, math a tan 2 y of x. What is a tan 2? Standard a tan 2. Function that returns an angle between a positive x-axis and the ray of the origin. A tan 2 is an argument of the thing, so if theta equals a tan 2y, and r equals this. So, yeah, I knew it. The arctan is equal to the y divided by x, but when x less than 0, the angle arctan y is diametrically opposite to the desired angle. Okay. And plus or minus pi must be added. Okay. I see. So what I'm going to do here is... let's do angle. Well, let's say that. diff1, diff0. Okay, so what I'm going to do is plus ops.pi times this is going to be diff 0 less than 0. Okay, so now I actually need to get my Boolean operators, but they're just going to do numbers, I think, as well. Up to. Or, gen, bin, gen. Okay, opcore. Less. 1.0 times less or equal greater or equal. Okay. So that means our op names less than will be less greater okay, less than or equal. And that means that we need all 4 of these in both ops and op-v. Okay. And here we would do a very, very similar thing, but we would just have type real at the end. So now we can have all of these operators that'll also be position or like rank polymorphic, which means they work on like lists of numbers as well. And that'd be op sv. Okay, so similar thing here, except for get rid of all those. And then we would do op VV here, so op SV. Okay, so this lets you compare one number to a bunch of numbers. These let you compare a bunch of numbers to a bunch of numbers. And then we'd have the same thing of op here, except for this would be op VS. And it'd actually do type.real. Okay, phew. And that means that now, I think all of these operators are now implemented. So that means that, for example, we could do pi times that. Oh wait, but we don't have pi yet. Type is type.real get math.pi. Okay, so it knows that one. And then this should be like a update once. Okay. Missing 229. Okay. And that means that once we resume, there we go. And then we'd add plus pi here. So yeah, let's add plus pi over 2. Okay, so now it works a little bit better, though it's not rotating from its center axis, which is because I just realized when we do a set transform, we should actually do our wait, I'm gonna go insane. I see. We should do maybe CWCH should be here. Oh wait, no. Okay, so now it's a little bit better, except for the fact that it pivots around that center point. And what I want it to do is not quite that. But I think I know. If we put it here. There we go, finally. So now we have a thing that rotates around an axis. I was gonna die, I was gonna kill myself in real life. Oh, but then we also should have the mouse in the correct position. Oh wait, it's because it does the zoom. Okay. So if we have that, well, Actually, what is the deal with this? Because that should all be good. But okay. Now what I need is the ability to shoot things. and we need to have things that come toward you. And neither of those are going to be terribly easy to figure out. Hmm. Let's pause. So I want the ability to shoot little bullets. So let's do like a 8x16. No. Hang on. Oh, I see. Boom. Okay, bullet. So this will be a tricky one, because what I want it to do is I want to create a bullet every time I click. For now, that'd be what I do. But basically I need something where I can set the value. So I'm going to do is status git add dot git commit m from farm to plate. So yeah, because at the very least I have a programming language where where I can now have like things that activate and they exist. The real challenge will be making it so that I can create things that exist. Let's see, this album's probably too intense. How long have I been streaming? I've been streaming for 8 hours. No wonder my head hurts so much. But okay, what I should do is get out of here. Because at the very least, well, you know what? At the very least, let's put this on itch. If I don't submit anything tomorrow, at the very least, this will exist. Let's see, where's itch.io. So we need to go to, what am I looking for? I'm looking for Langjam. Huh? Don't I have my jams that I like joined? Like the ones that I explicitly am part of right now? Okay. So I think the first thing I need to do is create a new project. Duet. Jam Game Jam. Let's just call it Duet 2025. A programming language and game. Actually, a programming language. No, you know what? I'm happy with the language. It's slow as hell. So the most tenuous game as of writing and a simple editor. Programming. Yeah. I guess I'll do that. I guess no AI. I mean, I did ask it why my thing was, why my screen was black, and then it didn't answer my question. Okay. So how do we add a web a web shot. So yeah, actually, I need to figure out itch.io upload web game. So itch supports uploading HTML games to play directly in the browser. In order for your game to function, it must be implemented using web technology such as blah blah blah. Okay. So head over to the new game or create an existing, pick HTML game, and upload the game packaged as a zip. So by embedding an iframe, okay, a zip that contains it, including an index.html, upload a single HTML file that contains your entire game. Okay, let's see if I can do that by, how do we change the type of this? HTML, okay. Repo. So let's just get this whole thing to a zip. Upload files, 35. So upload a zip file that contains your game. There must be an index.html or upload a .html that contains your entire game. Okay, so let's see if this will actually work. Because I have some doubts. But at the very least, this will be... Let's see if this works. It cannot scroll. Scroll bar. Some projects are designed to be larger than the frame. Enable scroll bars. Enabling scroll bars. They are hidden by default. Enable scroll bars. It is not mobile friendly. Save. Okay. Inspect. So why is this not working? Is there a console? Is there any issues here? Duet is not defined. Okay. Failed to load script with HTML classic source zone. Editor is not defined. Okay, so I think what this means is that I should have all of my, so if I have like, so here, I should do that. Slash. So any other places where I use slashes? I mean, I use them here. So yeah, it should be in the all relative to the thing. Okay. Oh, wait. But that means I have to upload a new zip file. Okay, delete that. Jesus fucking Christ. If you're gonna make me, like, upload, like, delete and upload every single time I do this, you don't have to make it, like, a, like, horrible thing. But this file will be played in the browser. Oh, yeah, what does it say? Yeah, this is in the browser. Oh, wait, we also need, like, 800 by... Wait, no. 800 by... 700. Let's do just 800 by 800. So that way it should show there. Inspect. So why is our debugger Duet? So we got Duet here. Yeah, we got duet.js, so it knows about this. But editor set content is not a function. Editor is not defined. And that's because the editor just isn't... No, the editor is here. Oh, but it's because... Scripts. Okay, hang on. Go back to my scripts. That also needs to be relative. Any other relative functions I should know about? No. Okay, okay, any other issues that I'm actually seeing? So editor is not defined, that's fine, okay. So it's basically these two, because set content is not valid, because when you go back to edit game, then we need to, I'm glad that this is a lot easier than I thought it was. I thought it'd be like, you'd have to, like, package it in a very specific way. But okay. And I think what I should do is I should also have it, probably, like, compile and, you know, I'm also going to make the... No, I don't care. I can't handle it. I'm going to say, yeah, for now, this is the thing. Okay, so let's see. The most tenuous of, the most meager of games and a simple editor. Let's do controls. How do we do headers? Is there like a preview for this? Because like, how do I... Okay, there we go. Do it. It's under the paragraph formatting, obviously. Okay. Huh? Okay. Left and right arrow keys were not working. Nothing's participating with me. But okay, a simple game. It's... Is there something that I'm blocking? I'm just going to turn this off here. So, set everything here to trusted. Oh, it's all trusted anyway. Is it because ad blocker's on? Everything's fucked up. Sure. A very simple game and an editor. For the language it's written in. So yeah, right now, it doesn't really work, but controls, in the editor, press Control plus Enter to compile and run. Game will be paused at startup. In the game, move with the arrow keys and aim with the mouse. No touchscreen. Sorry. It's close enough. Public. View page. Okay, and so now what I can do is I can go back to the Langjam Gamejam. There we are. So are there any other submissions? How many? Okay, there's quite a few submissions. Nice, nice. And you know what? I will have, let's make a cool image. It's going to be my cool guy. My cool man. Let's see. Let's make this here. And then let's do, okay, status. I am dying. Okay. I'm gonna do 500 by 500. I'm gonna show you all sorts of cool tricks. Alright, so we need... I'm gonna do input mono black, but I'm gonna make it white in a sick and twisted bout of irony. Oh. I swear the, font sizes are completely nonsensical. Like, they aren't actually correlated with how big the screen is or how many pixels it is. Because on a 1920 by 1080, I had to use, size 200 to make the font for the thumbnail of my recent video. And that's, much smaller than... it was, this size on the screen, basically. But, okay. Copy. So we're going to add a clone layer, and then we're going to add a filter mask, and then what we're going to do is Gaussian blur it, so it's all cool like that. And then what I'm going to do is I'm going to put that there. So now we have a clone that follows us. A loyal steed. What am I looking for now? 35 repo. Let's do, other cool image dot, yeah, say that. And then what I'm going to do is I'm going to dump in our assets, insert many layers. Where's our... I'm trying to get, the ability to, rotate the object without, I want to move the object. How do I move the object? Am I pressing, am I holding something? How is this not working? Okay. Beautiful. That's what we're looking for. And you know what? I'm gonna get another layer clone. Add clone layer, but this one's gonna be additive, and it's gonna have as well the whatever it has, filter mask. Look at that, that's cool now. Okay. And we don't have any blur, we don't have anything cool in it. But now I am technically on the board. I'm on the board for Duet. Ugh. So yeah, now we have all of the cool submissions. Okay. Close that. Get status. Git commit am thumbnail. Git add dot. There we go. Okay, from farm to table. I've written a thing that takes text and turns it into a big fucking mess. And I don't know how it works. And I don't know how to use it. But eventually, I'll write it down. The delusions of a madman, I'd say. But okay, I'm out of here. I'm gonna, like, go to sleep now. It's 8:30 and I'm exhausted. But okay, I'll see you Sunday for probably playing a few of those Game Jam games. But okay, take care.